So let's say you found a skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. Hopefully I have sorted out my mic placement and sound even more amazing this time around. Speaking of sound, here's how this video originally sounded.
As though Mother Nature has some intended goal that she sets out to achieve. The bacteria want to survive.
I had to spend a fair bit of time cleaning it up and dealing with corrupted files. So while the audio on the original video isn't great, it's a lot better than it used to be. Anyway, I'm here to respond to Jay Seegert. I don't think I've covered him before, but for some reason I'm convinced I know that name from somewhere. Anyway, he's here to tell us whether evolution is probable or problematic. I appreciate the alliteration, and this seems like it's going to be a grab bag of all sorts of creationist claims. Let's dive into it after whatever pastor is hosting Jay is done introducing him.
I have a very exciting talk for you. It's very unique. The first part of it's going to cover some basic things about how evolution supposedly works.
Put in the comments how many things you think he'll strawman in the first half.
And the last half or third or so is going to get into stuff that's really unique, really powerful, and also really easy to understand.
You know, I hear certain Christians describe things like Bible verses or sermons as powerful, and I don't really know what that means. I was an evangelical back in the 1990s, and even then, I only really thought of the word used in context like this to just mean profound or thought-provoking. But is that really all it means?
And it's one of the most powerful evidences that I know as to why evolution just isn't possible. So we'll be getting into that.
He's saving the best for last. I guess that means you're going to have to watch every part of this, too.
You know a little bit about my background. I usually say you may not know me from a hole in the ground, so I'll go over a little bit more background. There's me.
Yeah, he's going to do some jokes and intro stuff. I don't care to air that. He says that he was raised as a Christian and his mom led him to Jesus. Now, I don't really have much trauma or anything from my evangelical past. I guess I was lucky like that. But one thing I do remember being distressing is how the soteriology of this brand of Christianity interacts with children raised in the religion. You see, if you think that your eternal fate depends on whether or not you've asked Jesus into your heart, and according to the adults in your life, that's supposed to come as some big conversion event, but you've just always been raised within the religion, you don't actually have a conversion event, and you probably never will. But that raises the anxiety that maybe you're not actually saved. I mean, all the adults around you have a testimony about their conversion experience and their come to Jesus moment. I later learned that, yeah, those testimonies are, shall we say, embellished in many cases, and are less about conversion experiences than times of stress and anxiety in which those people leaned on their religion for strength, which I'm not knocking. Life is hard, and if your religion and the community associated with it help you to get through tough times, then good. I think that's when religious communities are at their best. But the thing is that this kind of soteriology is harmful to children. If you've experienced that stress and anxiety, I'm sorry. And people like Seegert should be too. We're going to cut back in with Jay discussing his university experience with professors who weren't feeding him lies, which he seems to have taken exception to.
They were all evolutionists. Some of them were atheists, and they were telling me that everything I believed was wrong.
First, I highly doubt that. I have been to university. I know several university professors and students. None of them are telling students that their beliefs are wrong or have been told that all their beliefs are wrong. Professors are there to teach the subject they teach, and yeah, if something we know in that subject goes against your beliefs, they'll teach it anyway. But they're also not here to convert you to atheism or whatever. Hey, Christians, you're not being oppressed when scholars tell you that you're wrong about something. But hey, if you want to actually help with real persecution of Christians, may I suggest helping out the St. Thomas Christians of India, an ethno-religious group that has been in India for nearly 2,000 years that was shattered by European colonialism. Or the Church of the East, which was scattered into diaspora as a direct and indirect result of the United States invading Iraq. Or the Coptic Orthodox Church, which is still facing kidnapping, forced conversions, and marriages, and bombings. Or the Eastern Orthodox Christians of Palestine and Syria, who are having their churches destroyed and worshippers killed by terrorists, including the Israeli government. You could actually do some good in the world by helping these people. You know, since the Bible has a lot to say about helping the foreigner, the orphan, the poor, and the widow. I don't know, maybe focus on the parts of the Bible that actually encourage doing good in the world instead of trying to drag science back in time 3 millennia.
And that made me very uncomfortable.
Wow, a white cisgender straight Christian man was made to feel uncomfortable. We should probably have the FBI look into this.
to be surrounded by those PhD scientists who I assumed they had a lot of evidence for what they believe.
A reasonable assumption, provided that the things they're assumed to be knowledgeable about are things that they teach and study, and not just random other stuff in which they have no expertise.
And I realized for the first time in my entire life that, yeah, I know what I believe, I just don't know why.
It's pretty obvious he believed because he saw the adults he trusted most in his life performing credibility-enhancing displays in the form of costly signaling through things like being cringy evangelists, spending time involved in not obviously productive activities like public prayers, Bible reading, etc. And he was also told that his response to the creedal statements of his parents' religion were the most important thing about him. That's why he believed. Now, those reasons may be different now, but at the very least, since up to this point he had not examined his beliefs about Christianity, I can say I'm right about why he believed with a high degree of confidence.
I couldn't defend a Christian worldview.
Something tells me that nothing about that has changed between then and now. I mean, he's a young earth creationist, and so, like with flat earthers and anti-vaxxers, it's basically impossible for him to be able to defend what he believes. Remember, among young earth creationists, well-informed and honest, you can't get more than 2.
I won't go into it now. I mentioned that I assumed my professors had evidence for what they believed, but I didn't have any for what I believed. I found out later they had nothing. And I mean literally nothing. I asked every one of my physics professors and thermodynamics and geology and all that. They didn't give me one example evidence to back up what they believed. That's a whole other story. But so anyway.
I'm calling bullshit, but I guess he doesn't want to go into it. After this, he gives a little story about how he started a ministry. Again, I don't care about these autobiographical details. I'll skip until there is something that I do care about. He also takes a weirdly long time to verbally fillet John Sanford. I didn't know he was in a throuple with Sanford and Sal Cordova. How progressive. And to think, I had earlier called him straight. My apologies to Jay. He also lets us know that he does Grand Canyon tours, and that may be where I've heard of this guy before. I kind of want to take a Creationist Grand Canyon tour. It would be surreal. Apparently, going on one of his tours will prove to you that Jesus is God and that the earth is young. That seems like a tall order, but I'm not going to let a creationist advertise on my channel. By the way, I cut out more than 11 minutes of this talk because it was all just commercials for his own ministry.
Now, how many of you ever seen Are You Smarter Than a Fifth Grader?
I have seen it.
A number of you. Kind of a dangerous program to watch. You might find out that maybe you're not.
Really, what you'll find out is that particularly bright children who are currently studying various things know more about those things than an average adult who is not studying those things. But ask those fifth graders about, say, your job, and they'll probably sound dumb. That's just how learning works.
We're going to change this up a bit and ask, are you smarter than a PhD scientist?
In some areas, yes. In some cases. I have PhD scientists ask me about things that they don't understand, but that I do, probably weekly. But what I don't do is think that I'm smarter than they are about their field of study. I don't assume Maddie is dumb every time I encounter something about meteorology that I don't understand or that seems counterintuitive, because she's the one who has spent years and years studying the topic. But let's be real here about what's going on. Jay is trying to encourage the evangelical tendency towards anti-intellectualism.
Now, most people would say, well, of course not. I mean, those guys are brilliant. I honestly believe after you hear this presentation, you truly will be smarter than most PhD scientists when it comes to the creation versus evolution controversy.
Damn, my X button just broke from all that doubting I just did.
Why is it? Is it because those scientists aren't very smart? Oh no, they're really smart. So I never argue with that. These scientists, skeptics, atheists, whatever, they're really, really intelligent. Obviously, the Bible says there's a big difference between intelligence and wisdom.
So does the D&D Player's Handbook. But geez, this guy can't get to the point. I'm skipping until a point.
Most PhD scientists don't even really know about evolution.
That's true for most PhD scientists for most things. Outside of their area of study, they're lay people.
They're making rocket fuel, cell phones, curing diseases. They're doing a whole bunch of stuff. They're not studying evolution. That's not their area. They're smart people, and they know their area.
And that's fair enough. But the problem is that there are in fact PhD evolutionary scientists, and pointing out that not all scientists are evolutionary biologists doesn't do anything to delegitimize the ones who are.
They just trust and have faith that the other scientists have figured out evolution. It's good enough for them. They don't need to know the evidence.
And that's how it is for virtually everything. Humans as a collective know too much for each and every human to independently validate all that knowledge within a single human lifespan. So you pick things you're going to learn about, and you just trust that the community of people who have picked some particular topic you didn't, and who have spent their whole lives dedicated to that topic, know what they're doing. And if in a particular instance you're not sure they do, you can check.
That's how it works. That would be a whole nother talk. But when you learn this about evidence for creation...
Wow, he claims to have evidence for creation. I've heard a lot of people say that, and none of them have been right to say it. Somehow, I don't think the third Mrs. Sanford here is going to be the one to break that trend.
You'll be better positioned to discuss the controversy than the majority of PhD scientists out there.
I'm pretty sure that's not even possible after a 1-hour talk that'll be mostly lies. But again, let's skip until he gets to a damn point. We get it. He thinks scientists are big dumb because he disagrees with them.
So since we're talking about evolution, we need to define it because this word is used in so many different ways.
Creationists say that, and strictly speaking, they're not wrong. But if you're talking about biological evolution, it's just change in allele frequency over generations or through time. That's it. If you want to talk about something different, like stellar evolution, which is an entirely separate topic, then it's the stages that a star goes through, from initial gravitational collapse all the way to its ultimate fate as a stellar remnant, such as a white dwarf, black hole, or neutron star. Now, I feel like I may want to define an allele. Various regions of the genome do things, like code for proteins, or regulate the production of proteins, and so forth. Each variation in any such region is an allele. So, for example, if we simplify a bit, and just assume that hair color is controlled by one single gene, each variation of it that results in brown, black, red, or blonde hair will be an allele.
For example, they'll talk about the evolution of the phone, how it's changed over the years. And we all know, yes, it's changed. They'll call that evolution.
But no one is calling it biological evolution or stellar evolution or anything like that. No one is using the change in the engineering design for telephones as evidence for universal common ancestry or the history of the universe as a whole.
I don't have a problem with that.
Then why bring it up?
They want to call that evolution, that's fine. That's not what I'm referring to this evening, and that's not what they're teaching in our school systems, but they use that term that way, and that's fine.
We are now 20 minutes into this talk and have not gotten a single actual point in favor of his ideas and that is problematic for science. How is the audience not revolting at this point?
I'm also not referring to different breeds of dogs.
Well, that's weird, because that absolutely is biological evolution. Dogs comprise populations of organisms that reproduce and vary in allele frequency, and even mutate to have new alleles. You can't get different distinct breeds of dog without evolution. Do you think that maybe there is a motive for his exclusion of what is obviously both evolution and undeniably real from his pet definition of evolution? I can think of some reasons, but none of them are what you might call honest. So I guess when it comes to the triangle meme, Jay has chosen young Earth creationist, and he has not chosen honest. It remains to be seen whether he has chosen well-informed, but based on the fact that he doesn't have any formal training in this, I'm guessing he only chose young Earth creationist.
We got about 350 breeds of dogs on the planet. I'm also not just referring to breeds of cats.
I mean, that's also evolution. I wonder how much evolution he'll just pretend isn't evolution by the time this talk is done. And conversely, how many things that aren't evolution that he'll include. If the only way for you to even make the argument is by redefining the topic, chances are you don't have a good argument. This also applies to John Sanford and Sal Cordova deciding to just change the definition of fitness.
I'm also not just referring to different beaks on finches that Darwin got very excited about.
Well, that's thing number 3 that's evolution that he's not talking about.
These are facts of science.
That's true.
And their evolution, making evolution, at least in part, a fact of science.
Nobody denies those things.
Okay, well then, I guess everybody is on board with evolution and my work here is done. If you liked this video, please hit like and let me know what you liked in the comments. If you didn't, then hit dislike and let me know what the problem was. Either way, I hope you subscribe and check out the channel memberships and my Patreon. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above.
But those things have nothing
Wait.
to do
What?
with evolution as they're teaching it in the school system.
I knew it couldn't be that easy. Damn it. Kids are taught that evolution is a change in allele frequency in a population over time. Dog breeds, cat breeds, and tanager beak size differences all arise through that exact means. So they are all evolution as it's being taught to kids. Now, that's not all that they're being taught, but it is certainly part of what they're being taught, and rightfully so.
This is what they're teaching in the school system, and this is what I'm referring to this evening.
Well, so far, this looks like a sphere someone dropped into a 3D program and deformed, then made a shader that gets brighter as the angle of incidence to the sphere gets shallower. Look, watch me do the same basic thing in real time in Blender. Okay, so here we are in Blender 4.5. This is the default scene. We're just going to get rid of everything. We're going to then add in an icosphere. We're going to bring this up to, like, I don't know, 4 division seems pretty good. Set this to shade smooth. Then we're going to go over to our modifiers. We're going to add a deform, and we're going to look for displace, new texture. We're going to make this clouds. So over here, go to clouds, cool. We're going to turn the strength down a little bit. There we go. Okay, here comes the actual magic. We're going to go over to the shader editor. New. Don't really need this. We want an emission shader. All right, we're going to make it a funky little green color. All right, then we're going to use a layer weight. Wow, look at that. We can change it to make it look a little bit better. We'll put in a color ramp. And we'll just up that contrast just a little bit. Maybe put it on B-spline. Then I can add in a new tag here. Cool. Now let's make it a little bit more complicated. We'll add in a, we'll make this have a subdivision. Pop this up here. Oh look, now it's even more complicated. And if we want to make sure that it's never completely black like it is here, we can just add in a math node on add, and this will set our minimum. So we can say, all right, well, look at that.
They tell us 3.8 billion years ago, non-living chemicals came together to form a living cell, and then that living cell turned itself into every other life form on this planet over millions and millions and millions of actually a few billion years.
Yes, that is also a part of evolution, but that it's not the same part as dog breeds doesn't make dog breeds not part of evolution. Look, making tempered glass with the correct curvature is part of making a car, and it doesn't stop being part of making a car because you want to talk about how body panels are attached to the chassis. It's fine to want to talk about universal common ancestry and not say about breeding in domesticated animals, but pretending that that makes one of them not evolution is just lying or profound ignorance.
That's what they're teaching as evolution. They're teaching it as a fact, typically. I call it a story, and I'm not trying to be condescending or sarcastic or disrespectful.
Well, it is a fact and a story. Those categories are not mutually exclusive. A fact, in this case, is something that is so likely to be true that to reject it would be perverse. A story is a narrative about a set of events that proceeds from a beginning to a middle to an end. So if a story is relating only true things, then the story as a whole is in fact a fact. For example, if I told you the story of how I got up this morning, took a shower, grabbed some coffee, found out that a guy I had reacted to on Vishanti's story was also a violent kidnapper and child abuser according to the Oregon courts, and then sat down to write the script, that story would be a fact.
I'm being literal. It is a story. They weren't there. They didn't see it happen. They're telling a story of what they imagined happened millions of years ago.
Stories have nothing to do with whether the storyteller was there or not, nor does the storyteller having been there or not tell us whether the story is true. This is just basic what the words mean.
We also call this molecules to man evolution.
Yes, he calls it that, as do many other pseudoscientists. But no real scientists call it that, because the formation of life and the evolution of life are not the same thing. Evolution is something that happens in populations with heritability and imperfect reproduction. The origin of life didn't involve such populations, and so while there are some overlapping mechanisms, such as selection, they are not the same thing. Evolution is something that only occurs after life has come about, and it doesn't really matter how that life originates. If it originated by God speaking it into existence, by Q stirring a pool of amino acids, or by the old one seeding life across the galaxy while building the webway, evolution still works, common ancestry is still true, and humans are still filthy monkey men.
I would highly recommend you use that phrase.
I wouldn't, because it's a dead giveaway that you either have no clue what you're talking about, or that you're a liar.
If you just tell someone you don't believe in evolution, they're going to think you're crazy.
No, I won't think you're crazy, I'll assume that you're badly misinformed. That's why I didn't believe in evolution, and for most people, it's a far better explanation. Believing something that's false isn't the same as being crazy or delusional. Delusions happen when an obviously false belief that is not one generally accepted is believed despite all evidence to the contrary and maintained despite new evidence to the contrary, usually through tortured rationalizations. Most people are not doing that when they don't believe in evolution. They don't know the evidence and usually are in spaces where rejection of evolution is normal and not questioned. In that sort of case, not believing in evolution is the normal thing to do.
Why? Because we see change all the time.
No, if you say you don't believe in evolution, people won't interpret that as you not believing in change. They'll correctly interpret that as you not believing in the basic foundational fact and theory of all of biology, biological evolution. That's because evolution is not generally used as a simple synonym for change in English. Because the only people who typically say things like, I don't believe in evolution, are creationists of various kinds, and they mean biological evolution, and sometimes other things from science that they reject, like the Big Bang or stellar evolution.
What just happened here? It's technically called equivocation. You set two things equal that are not equal. Evolution and change.
Near as I can tell, no one is doing that, except possibly Jay, since he seems to think that things that definitely are evolution aren't, and I'm guessing he's going to call them change. But technically, he hasn't done that yet, so at this point, there still seems to be no equivocation going on. Now, it is the case that universal common ancestry and the actual process of biological evolution are often called evolution, which can be confusing in some contexts, but that's an example of a word having more than one meaning, which is not in itself equivocation, although it's needed for equivocation to occur.
Now, evolution would involve change, but it's not just any kind of change. It's a very specific kind of change that makes things more complex and adds new information.
No, that's not what it is. Evolution can do those things, but it doesn't have to be evolution. Anytime the allele frequency in a population varies over time, that's evolution. Now, that might be variation in ways that lead to more complexity, but it could also be variation that leads to less. As for information, since I don't know what Seegert means by that word, and since most creationists themselves don't know what they mean by that, I'll just use the definition which is actually measurable. That is, the amount of genetic material in the genomes of the members of a population. In that case, duplications and insertions create information, but deletions reduce information, and both are part of evolution. So evolution both increases and decreases information in genomes. We're already off the rails, and the talk has barely begun. This is why it's important to not just define your terms, but to use definitions that are actually recognizable to people who know the subject that you're talking about. If I decided to give a talk about chess, and I define check as any time either the king, queen, or white bishop is under threat of capture on your opponent's next turn, I would not be talking about what actual chess players are talking about when they say check, even though what they mean is also in my definition. My definition would mean that virtually nothing I said about check would correspond to anything in the reality of chess as it is played in the real world. Similarly, by getting what evolution is fundamentally wrong, J. Seegert's talk is almost guaranteed to have little or nothing to do with what evolution actually is, how it works, how we know about it, or what the evidence for it is.
We never see that kind of change.
Yes, we do. We saw it in real time in the Lenski long-term E. coli experiment, where the bacteria in the experiment added new genes and a whole new regulatory pathway. That's adding both complexity and information. And since he likes dogs have added new genes and new facial muscles compared to wild wolves to help them communicate with humans and eat starchy human food. That's an increase in both complexity and information right there. Wolves can't eat a starch-heavy diet and be healthy because they can't effectively digest carbohydrates. They get very few calories from them because they don't produce enough amylase to break down carbs efficiently. Dogs, on the other hand, have extra amylase genes that express in more parts of the body, including the salivary glands, which allows them to derive far more calories from foods like grains. Also, you know that adorable, sad puppy dog look that makes you want to give your dog whatever he or she wants? Yeah, that's a result of facial muscles around the eye that no other canids have.
So, if you say you don't believe in evolution, the skeptic will think you deny change, and they're going to think you're crazy, and they should.
No, they won't. At least they won't think that you deny change broadly. They might think that you're crazy, I suppose, but I won't.
So don't just say you don't believe in evolution, say you don't believe in molecules to man evolution.
Or better yet, if you really need to be specific, say that you don't believe in biological evolution.
You don't believe that dead, non-living molecules came together to form a living cell.
That's how living cells come together every time they form. Leaving aside the matter that dead means something that was once alive and that these chemicals are inanimate, not dead, all cells are composed of non-living chemicals. Those chemicals are assembled into new cells every time any new cell is made. That's how cells work. The question of origin of life research is how can and did that happen if there was no cell to facilitate it in the first place? But the bare fact that living cells are composed of non-living chemicals is just inarguable.
And then that cell turned itself into every other life form, including human beings.
No, that cell didn't transform itself, it reproduced. And the daughter cells were not identical to the parent cell. Some of the changes to the daughter cells helped those cells proliferate in different environments, and so life diverged into different species, a process which continued for billions of years, eventually leading to modern life. But that original cell is long gone, and it was long gone even by the time the last common ancestor of all extant life evolved.
Now, here's a general premise of this talk. Certain things look pretty good from a certain angle or certain distance, like this bright red BMW. You envision opening the hood and seeing a beautiful engine there. What if you opened the hood and you saw this? The engine's missing. A bunch of wires are hanging there. So what looked pretty good at first, upon closer inspection, doesn't look so good anymore.
Then it's not a very good car. Do we really need an analogy for this? I guess, who am I to talk? I make analogies all the time.
That's what we're going to see with evolution. And it doesn't take much imagination to envision evolution occurring as they teach it in the school system.
Is the implication here that something that is easy to imagine is likely false? I'm not sure what he's getting at. I suppose I'll let him cook.
You can use your imagination. For example, we've got two creatures here, a snake and a lizard.
Couple things. Snakes are lizards, so saying you have a snake and a lizard is a bit like saying you have a dog and a dachshund. Second, that's not a lizard, that's a salamander. Specifically, the snake is a dark morph Burmese python, Python bivitatus, and the salamander is the fire salamander, Salamandra salamandra. In case you're wondering, reptiles did not evolve from salamanders.
These two creatures are not completely different.
That's true, they're both tetrapods, tetrapods being a group of mostly terrestrial lobe-finned fish that share adaptations to breathe air efficiently that generally lack any form of gill as an adult, and that at some point in development have 4 limb buds.
There are a number of similarities there. It doesn't take much imagination to envision bumps starting to form in that snake.
It doesn't require any imagination. Here's an actual photograph of a snake with legs. They're simple legs, but also legs didn't evolve from limbless snakes growing legs. They evolved from the fins of lobe-finned fish. Snakes lost their legs. They're not the ancestral no-limb form.
And then the bumps get bigger and bigger and bigger and longer. They kind of evolve into the legs of the lizard.
Which again, isn't a lizard. It's so much a salamander that its Latin name means salamander salamander. It was described by Linnaeus in 1758. This isn't just a salamander, it's the salamander.
Just small little changes over millions and millions of years.
But not those changes. Those changes are a straw man of the history of limb development in tetrapods.
That doesn't take much imagination, and that's, again, what they're teaching in the school.
I can guarantee you that no school is teaching kids that salamanders evolved from snakes growing legs.
But if you were to pop the hood to look inside these creatures to see what has to happen in the DNA, that's when you find out that can't happen.
That's a fun assertion. I wonder if he'll bother to back it up any. My money is on no.
So we're going to be popping the hood throughout this talk.
That sounds like a euphemism. I'm not sure for what, but if you come up with an idea for what it is a euphemism for, put it in the comments. I know I have an audience that's much more creative than I am, especially collectively. I'm sure we can come up with some really good options for what pop that hood might mean.
Richard Dawkins.
Richard Dawkins. I am so sick of having to talk about that shit stain. Not only is he a bigot, he's also probably the worst thing to happen to the philosophy of religion in the past couple of centuries. The God delusion was such a disaster, and that was before he just came out as a raging transphobe and Islamophobe.
Arguably the world's leading atheist.
Very arguably. I'm not sure what it would mean to be the world's leading atheist. It's not like there are atheism Olympics and he got the gold medal, or that there are atheist rankings like there are in chess and he's got the highest number of atheism points.
I like Richard Dawkins. I appreciate his being pretty straightforward as an atheist. He just says it like it is, and I appreciate that. He probably wouldn't like me, that's fine.
He actually might like Jay. He's taken to calling himself a cultural Christian, and I'm sure that he and Jay here share some bigotries that they could discuss over a pint of beer. Who he probably wouldn't like is me or my supporters, who are either supportive of trans rights or just trans. And by the way, if you're not supportive of trans rights, I don't need your support. If you don't think that my friends, supporters, and loved ones should be allowed to exist, you can just leave. No, I don't want to debate it with you, because when the options are someone who just wants to exist in a way that both harms no one and reduces their mental anguish, and you want to stop that, there is no debate to be had. I won't debate the validity or existence of people who just want to try to live their lives.
But this is one thing that he said. You cannot be both sane and well-educated and disbelieve in evolution.
I agree, although I would add that you can lie about it and be both sane and well-educated. Also, it feels gross to agree with Richard Dawkins. Surely someone has expressed this sentiment who didn't then go on to deny the science about sex and deny the humanity of others.
The evidence is so strong that any sane, educated person has got to believe in evolution.
Yes, or they need to lie. Lying seems to be a very common tactic among those who make it their business to spread anti-science ideas.
Very dogmatic, intimidating statement from a pretty intelligent scientist.
No, it's not dogmatic at all. If it were dogmatic, it wouldn't be about evidence, because dogmas are those beliefs that are held regardless of evidence, or which are required to belong to some organization, generally a religious one, although it could also be a political or even a fandom group. Dawkins' statement isn't any of those things. A dogmatic belief isn't the same thing as a well-evidenced belief, or a belief that's strongly held to. But of course, dogma often has a bad connotation, and so Jay is capitalizing on that and using that reputation to suggest that all the bad things about dogma can be applied to Dawkins' position, while ignoring the fact that between the two of them regarding evolution, it is Jay who is in fact the one being dogmatic.
So again, imagine your children or grandchildren sitting in a classroom hearing the professor or teacher saying something like this.
That would be a really weird thing for a teacher to say. Teachers are there to make sure that students understand the material, not so much that they accept it as true. I know, I have taken classes where I disagreed about the conclusions of the professor or teacher teaching the class. They didn't really try to convince me otherwise, at least not during class time.
How are you going to push back? If you say you don't believe in evolution, you're announcing to everyone around you, I'm one of these insane, crazy people.
No, you're more likely telling people that you're not well educated. In fact, the part I disagree with Dawkins on about this topic is that I find it is far more likely that those who reject evolution are in fact immoral or poorly educated, rather than that they are insane in some way. I find very little evidence that would suggest a mental disorder in most creationists, apart from some of them who seem to be narcissists like Kent Hovind. And far more often, I find that they are just bad people who are happy to lie, as long as they can say they did it for Jesus.
I deny science, I just believe the Bible.
Way to tell on yourself, Jay.
So most of the students become very quiet, and right now about 77% of Christian youth are walking away from their faith during college.
If your religion can't survive basic science education, then it's probably time to get a new one. And that doesn't even mean that you have to get rid of Christianity. There are plenty of varieties of Christianity that aren't out there denying demonstrable facts of science.
Even if they don't go to college, about that time in their life, they're walking away.
Wow, they can't even keep people when they don't find out that so much of what they were taught about the history of the world was just lies. Maybe instead of doubling down on lies, fundamentalist evangelicals should take a long look at themselves and figure out what it is about their religion that is repelling people. Maybe it's the bigotry. Maybe it's the science denial. I don't know. I'm not here to rehabilitate the Christian denominations currently trying to kill pregnant people and push anyone who isn't cisgendered and heterosexual back into the closet in the best case scenario. But hey, maybe those very things might need some introspection, evangelical Christians.
Partially because they were handed a set of beliefs without convictions. So that's a whole nother talk that I'm not giving this evening.
Ah yes, they're leaving because we don't browbeat them hard enough. I'm sure that's the reason.
Proverbs 18:17 says the first one to plead his cause seems right, until his neighbor comes along and examines him. We've all been in that position before where you hear something and you're thinking, you can't argue with that. But someone else comes along and says, well, wait a minute. Did you know about this or that or that? Oh, no, I didn't know about that. Okay, I guess this thing doesn't sound so good anymore. Well, I kind of jokingly say Evolution 1:1 says the only one to plead his cause seems right, because no one else is allowed to challenge him or present other views.
No, everyone has a chance. To plead the case against evolution, you have to go to the scientific literature with your data. Creationism already did that over a century ago. It failed. It was assigned to the dustbin of scientific history with the phlogiston theory of fire, the miasma theory of disease, geocentrism, the steady-state universe, and the luminous first ether. These were the dominant paradigms in their respective fields of study for decades or centuries. Phlogiston was replaced by the oxygen theory of fire, miasma was replaced by the germ theory of disease, geocentrism was replaced with heliocentrism, and while that has been replaced with a barycentric model, it's so close to being true that we teach it. The steady-state universe has been replaced with the Big Bang, and the lambda CDM model. The luminiferous ether has been replaced by relativity. Special creation has been replaced by evolution. If you want to bring back any of those now long discarded ideas, you're going to have to do it with data, and not from a church pulpit or classroom. The fact is that for the most part, creationists don't even try.
This is what we have in our public school system. They're only presenting one view, so of course it's going to seem plausible.
Yes, until you're getting a degree beyond primary education, the goal of schools is to teach the broadly accepted consensus. Until creationists can change that consensus, then their ideas should not be taught in science or history classrooms.
And if a student raises their hand and says, well, what about creation? Oh, thank you for bringing that up. See, now that's a religious view. And separation of church and state. You're here in the school system to learn truth. This is a science classroom. We're going to teach you what's true. You want to learn about creation. That's a mythical thing. You can read the Bible or something like that, but this is a science class, and we talk about truth. The scientists have proven evolution.
I can't say that response would never be given, but it is not the correct or most likely response. The response is more likely to be, that isn't part of the science standards, and so we do not teach it. But if you want to discuss that, we can do it outside of classroom time. Science standards aren't going to be changed by a student disrupting science class. Again, if creationists want their ideas taught in science classrooms, then they have to start getting scientific backing for those ideas without telling lies. I happen to think that's impossible, so it's not going to happen. But hey, creationists, I'd love to be proven wrong about that.
If they ever find out there's another option, they'll let us know, but they've already proven evolution is true.
Other than quibbles about using the word prove in regards to science, yes, if the scientists now find an actual option that isn't evolution to explain biodiversity and population genetics, not only will they let you know, there will be some Nobel Prizes coming and huge press releases. You'll know if that happens.
Here's an interesting quote from Dr. Eugenie Scott. She's now the former executive director of the National Center for Science Education. This was an organization that was drafted to combat biblical creation.
Specifically, it was created to oppose efforts to get creationism into science classrooms because not only is it a violation of the Establishment Clause of the formerly enforced Constitution of the United States of America, and thereby would be illegal if any country under that document still existed, which was the case when the organization was established, but also because creationism isn't science and so does not belong in a science classroom, regardless of any legal questions.
And this is what she said. In my opinion, using creation and evolution topics as critical thinking skills or exercises in primary and secondary schools is virtually guaranteed to confuse the students about evolution and may lead them to reject it.
I never thought about that. Seems plausible. I'm sure other people, including some of you watching, know far more about pedagogy than I do, and so would be far better equipped than I am to assess this statement. If you are someone with a background in teaching, let me know what you think of Scott's statement.
What is she saying? She said, we can't teach both views. That might lead some students to reject evolution. We can't have that. We can't allow that. So we're only going to teach one view.
Okay.
How can you teach critical thinking if you're only giving one option? They have nothing to compare it to.
Creationism, as believed by fundamentalist evangelicals, is not the other option in a dichotomy with evolution. In fact, here's an example of a question that could be used for homework or classwork to get a student to think critically about evolution. John says that sharks and dolphins must be very closely related based on their overall body shape and the similarities between the shape and placement of their fins or flippers. Maria disagrees and says that those aspects are convergent and that dolphins and sharks differ in many significant ways. Discuss who is more likely correct and why you have come to that conclusion. The question could also attach anatomical diagrams of the two animals in question. There you go. You had contrasting views about evolution in a question that requires critical thinking.
So that's how they get away with it. They're not going to contrast in whether things happen by themselves or they didn't.
No, the dichotomy he's proposing is whether things happened according to natural law or by miracle.
And they could teach it that way. They don't need to teach in the classroom that God created Adam and Eve in the garden and Adam and Eve sinned and got kicked out and all that. But they could teach, you got two options. Either everything came into existence by itself or it didn't.
Well, since we have no evidence of supernatural agency in biology, teaching that as an option would just be making things up which are untestable. That's kind of the opposite of what science does.
Is that a religious statement? No, that's logic.
But it can also be used for literally anything. Maybe things fall down on their own because of gravity, or maybe someone pushes them down. Maybe weather happens on its own as a result of fluid dynamics and energy from the sun, or maybe someone is making it rain through magic. Maybe computers execute tasks by themselves via electricity, circuits, and math, or maybe each one has a tiny little demon inside that tells your monitors what to show. Maybe wildfires start by themselves in hot, dry environments and then spread all on their own. Or maybe they're actually started by Jewish space lasers that for some reason are targeting suburban homes and commercial districts. Why are these any less valid to teach? I don't think they are, but I bet Seegert wouldn't want any of them taught except maybe the Jewish space laser thing. I'd say there's a very good chance he thinks that's a plausible thing.
And then the rest of the semester, they can just do good science, and the students can decide, does what we just discussed today in class support the idea everything happened by itself, or didn't?
It's going to broadly support the consensus view, because the consensus view got to be that way by having the most evidence and the best predictive power.
They could do that, but they won't.
Right, because it's stupid and confusing for the children.
Teaching one view, we know it all happened for no reason all by itself.
No, what we know is that evolution occurred and all evidence is compatible with it happening according to impersonal physical processes, and there is currently no reason to think that an outside agency is required to explain anything about it. I don't know if that means all by itself and without God or whatever, but that's what we know, and that's what we should teach.
So, we don't have time to go over the big picture. I cover it in some of my other talks, but if we were to touch on the big picture, we would discuss the origin of a bunch of things, like the origin of stuff.
We are right now 26 and a half minutes into a talk about this. The talk itself is an hour and a half long. We have plenty of time, but for some reason, Jay used nearly the whole first 50 minutes on autobiographical nonsense and advertisements for his ministry and Grand Canyon tours. If he thought this stuff was important, he could have talked about it. But what he thought was more important was his own ego and making money by lying to tourists. Also, I want to point out that this talk is supposed to be about whether evolution is probable, and we haven't discussed that at all, even though we're almost a third of the way through the talk.
Matter and energy. Like, okay, where'd stuff come from?
Energy seems to have always existed in some form or another, although it is possible that the total sum vector of all energy in the universe is actually zero, in which case it can simply come into existence from fluctuations in various quantum fields. Stuff by which I assume he means matter is itself made of energy, and so it came from the energy.
There's an entire massive universe out there. Like, if there's no God, please tell me how it came from. I got a series on the origin of the universe. You can.
I just want to point out what happened there. Of the universe, he started with a question. Please tell me how it... and then launched right into a commercial for his cosmology series. Amazing. I don't think I've ever seen a creationist speaker who was so nakedly interested in advertising his own stuff. Although, to be fair, he is offering those videos for free, so it's not just money he's looking for. I'm skipping his commercial, of course.
So you talk about the origin of stuff, and then once you have the origin of stuff, how does it organize itself into stars, galaxies, and planets?
Gravity.
The laws of physics mitigate against that.
Hey, guys, gravity isn't a law of physics anymore. Interesting news. Odd that I'm hearing about it on a low-quality live stream from some church and not, the news and physics journals.
And once you have stars, galaxies, and planets, how do you get dead chemicals to come together to form a living cell?
I don't know, but people are working on it, and they are making progress. But what we don't have is evidence of intelligent agents making it happen in the deep past. If creationists obtain evidence, then they should present it for peer review. What they should not do is just declare that until we know, it must be not just a god, but theirs specifically. Also, I want to know that as his picture to illustrate life, he has a virus, which is not seen as living by many biologists, so it's an odd choice, especially given that he could have chosen a bacterium or something.
And then you talk about the variety of life. Once you have a living cell, how does it turn itself into the millions of species we have today?
Mutation, natural selection, genetic drift, horizontal gene transfer, etc. Evolution. The thing we're supposed to be talking about based on the title of this talk, which is Evolution, Probable or Problematic, but which we've talked about very little. Gee, I hope I don't have to keep repeating this answer.
We're going to focus more so on this last one here, the origin of species, in a sense, the variety of life. How do you take a single-celled organism and turn it into every other life form, including human beings?
Mutation, natural selection, genetic drift, horizontal gene transfer, etc. Evolution. the thing we're supposed to be talking about based on the title of this talk, which is Evolution, Probable or Problematic, but which we've talked about very little.
Well, there's a lot of arranging and storytelling that goes on when teaching evolution.
Oh great, we're about to use vehicles as an analogy for living things. That's always a good idea, and never a disanalogy.
As an analogy, I put 4 modes of transportation up on the screen.
None of which can reproduce or have genetic material, which means they're going to be bad analogies for a process that's all about reproduction and genetic material.
We could arrange these things from simpler to more complex and discuss the evolution of the motorcycle.
Yes, we could, but since vehicles have no genetic traits, have no inheritance from ancestors, and are all known to be made by people, while organisms do have genetic traits, inheritance from ancestors, and are known to be not made by people, I guess with the exception of new people, the vehicles are a poor analogy for evolution, because they have none of the characteristics needed to evolve in the first place. This is like comparing different sizes of sports balls, and then deciding that you can arrange them by size, like we do with stars, and then also saying that because none of them do nuclear fusion, therefore, the sun doesn't either. It's so stupid, it's hard to believe anyone would do this in good faith.
You see what happened? So we used to have tricycles, and then those small little wheels in the back got together to form the larger back wheel of the bicycle. And then the change of the bicycle eventually turned into an electric motor of the scooter. And then the electric motor of the scooter slowly evolved into a gas combustion engine. That's how we got motorcycles.
And if these vehicles were not man-made and could reproduce with heritable characteristics, some of which mutated, and there was an actual aspect of their reproduction which was biased towards some character states and against others, then that actually would be a plausible explanation. The reason this is implausible is because we know that's not how these vehicles are produced. But since it is how life is produced, the only part of this that is implausible is the part of the analogy where the analogy breaks down, making this a useless analogy for arguing against evolution.
No, that's a really silly story.
That's true.
But not for reasons that actually matter to the story of life on Earth.
But all I did is I took real things and lined them up from what appears to be simpler to more complex, and I told you stories, how little changes here and there over time. That's what happens when they're teaching evolution.
Except that when they're teaching evolution, things are under no obligation to forever complexify. And we have things which actually can undergo directional change and radiation because of their methods of reproduction. And on top of that, some of the things that we put in our charts were not discovered before the idea of universal common ancestry, but were predicted and later found based on that idea, meaning that they're a confirmed prediction. That you can make a parody of an evolutionary sequence with non-living objects does nothing to argue against the theory of evolution. To flip this around, the fact that The Life of Brian is a movie that parodies the life of Jesus is not a good argument that Jesus isn't real, as I'm sure Jay would agree.
Here's a real-life example, the evolution of the horse, from Eohippus all the way to the modern horse.
Yes, and those animals are capable of reproducing via genetic material that can mutate, and such mutations can have effects on the future reproductive success of the animals in question. And further, the more derived horses are consistently found above the earliest examples of the more basal horses, and that horses evolved from four-toed animals is a prediction of evolution that was made before the fossil record of horses was well established. So in point of fact, this is exquisite evidence for the evolution of the horse. Now one thing I will say is that the arrow in this graphic implies that this evolution was both orthogenetic and characterized by anagenesis. That is, it followed a set path as if by evolutionary momentum, and that every species evolved directly from the previous species and replaced it entirely. This is not the case. In reality, there were lots of side branches in horse evolution. Many more basal forms survived alongside more derived forms, and it is generally, although not always, impossible to determine if a fossil form is directly ancestral to a later form, whether fossil or modern, or if it is simply a close relative of the ancestor of such forms. Really, the evolution of horses looks more like a branching tree, because that's what evolution does. It makes branches. But also, this sequence poses a bit of a problem for creationists. Generally, creationists don't say that God created every single species that we now have on Earth, or see in the fossil record, as a separate creation. Instead, they suppose that he created what they call kinds, which they tend to conceptualize as members of a Linnaean family, leaving aside that which groups of organisms count as a family is fundamentally arbitrary, which means it should be impossible to assign that rank as a level of the kind. All the animals he is considering from Eohippus to Equus are all in the family Equidae, and so what was on the ark would be more like Eohippus than anything else. Indeed, the ark encounter run by Answers in Genesis bases their horse kind on the ark on Mesohippus, So at least from Mesohippus on, this evolutionary progression must be somewhat true, even under young Earth creationism.
I'm going to give you a quote from Dr. Niles Eldredge, one of the world's leading evolutionists.
Nah, we're not going to go to a quote-mined argument from authority in which we quote Gould or Eldredge arguing against what they called gradualism in favor of punctuated equilibria, but that Seegert is going to pretend is an argument against morphological evolution overall. He can make that argument himself, and I'm tired of allowing creationists to shit all over the memory of Eldredge and Gould by lying about them, what they said, and why they said it. In this specific case, Eldredge is just arguing against the orthogenetic presentation of the horse sequence, and yeah, it wasn't orthogenetic in reality.
And it probably shouldn't be in the textbooks. Okay, I agree with that. Then why is it in your museum?
Well, if by that he simply means, why are these forms presented as part of the true story of the evolution of modern equids like the horse, zebra, and donkey? It's because they are. If he is actually asking the same question as Eldredge, why is orthogenesis still presented in textbooks? It's usually not, from what I can tell. Friend of the channel, Jackson Wheat, who has his own excellent channel, by the way, has a number of biology textbooks, and a couple of them have sections on horse evolution. The first is Biology for Life with Physiology 6th edition, which is copyrighted 2019, so fairly recent, and basically the future as far as creationists are concerned. It has only a small blurb and a simple diagram. It includes Eohippus, Mesohippus, Merychippus, and Equus, showing the loss of toes and the increasing robustness of digit 3, the middle finger or toe. It simply says, quote, horse fossils provide a fairly complete sequence of evolutionary change from small cat-like animals with 4 toes to the modern horse with 1 massive toe, end quote. While this is still a bit too orthogenetic in character for my taste, it is not directly stating that it was a smooth transition from one to the other, and so I would say this doesn't quite meet my or Eldredge's ideal, but it's still better than it could be. A more thorough treatment is found in Campbell Biology, Concepts and Connections 10th edition, copyrighted 2021, so even more recent. This has a diagram with some 23 genera listed, the addition of a depiction of Anchitherium, and no hint of orthogenetic evolution. The text accompanying the diagram reads thus, quote, did the horse lineage progress gradually toward larger size, reduced number of toes, and teeth adapted to grazing? Figure 15.13 shows the fossil record of horses with vertical bars representing the period of time each group persisted in the record. If you follow the fossil species highlighted in yellow from the bottom to the top of figure 15.13, it appears that the modern horse evolved linearly from Hyracotherium to Equus, through a series of intermediate forms. However, if we consider all the fossil horses known today, this apparent trend vanishes. The genus Equus actually descended through a series of speciation episodes, not all of which led to large one-toed grazers. The present-day horse is the only surviving twig of an evolutionary tree with many divergent branches. Branching evolution can lead to a real evolutionary trend, however. One model of long-term trends compares species with the individual. Speciation is their birth, extinction their death, and new species that diverge from them are their offspring. According to this model of species selection, unequal survival of species and unequal generation of new species play a role in macroevolution, similar to the role of unequal reproduction in microevolution. In other words, the species that generate the greatest number of new species determine the direction of major evolutionary trends. End quote. This is pretty much spot on for what Eldredge was asking for, and so we can see that at least in some textbooks, the orthogenetic evolution of horses is not only not taught, but it is explicitly taught against. Seems like we're doing just fine on the equid evolution education front. Now, of course, because Jay is lying about what Eldredge said, and is pretending that he said that we have no evidence for horse evolution at all, he'll pretend that any information indicating that horses evolved based on the fossils is known to be false, even though his own view requires that it be true, at least to a large extent.
Well, I mean, it costs money to change the museums.
That's true. That's why museums are always going to lag behind the literature when it comes to new findings.
And if you took that out, you'd have this big gaping hole and nothing to put in its place. So they kind of leave it there and imagine the millions of students and adults filing through, seeing fossils lined up like the bike and the trike and all that, with little plaques with the stories. Oh, this changed into that. It's like, you can't argue with that. That's science, right? No, that's pictures and little words making up stories.
Yeah, it's true that if that signage isn't changed, then visitors to the museum will get an inappropriately orthogenetic view of horse evolution. That's not great, but also, in the grand scheme of things, it's not exactly a travesty, and it's easily corrected if they care to actually dig into the topic. Further, I can't seem to figure out what the current signage at the museum says, but their website says the following about the horse evolution exhibit. Quote, the museum owns the largest collection of fossil horse skeletons in the world. Since the early 1900s, the exhibit has shown a classic linear progression of evolution. Today, the display also offers a more current view of evolution with a complex branching history. Cladistics, the grouping of organisms by shared specialized characteristics, shows that some later horses, such as Calipus, are actually smaller than earlier ones. It also shows that other later horses, such as Neohipparion, still had 3 toes. All modern horses have 1 toe. End quote. So at least on their website, this problem has been fixed, and the website claims that it's been fixed in the signage too. Of course, Jay is lying about what the problem even is, so he wouldn't consider it fixed, but Eldridge would.
But it's in the museums.
Tell you what, if Jay ever sees this video, he's welcome to email me and we can collaborate on figuring out how to get orthogenesis out of museums. Somehow, I don't think he'll bother though. One thing you should bother to do though is to subscribe to the channel, hit the like button, and leave a comment. All of those help the channel grow, something that has been hard to do for a lot of YouTubers lately, myself included. It shows YouTube that you like this content, and it is content you want to see, and it will recommend it not only to you more, but also to others who have not seen my videos. It's the best way you can help the channel short of financial support, and even if you are supporting me in that way, why not help out this way too?
The Book of Life, written by Stephen Jay Gould. He was one of the world's leading evolutionists, passed away, I think maybe in 2007 or something.
Oh great, we get to hear more lies about Stephen Jay Gould, or at least that's what I'm expecting.
But this is what he illustrated in this book, how fish evolved into amphibians over millions and millions of years. Okay.
That seems like more of an illustration that they did rather than how they did, but sure.
What did it look like in the middle?
Like this. This is Tiktaalik, a transitional that's smack in the middle and exactly what Jay is looking for. In fact, it was found by a team led by Neil Shubin, who used old Earth geology and evolutionary biology to predict the location where they should be likely to find just such a transitional form. And it turns out that it was in one of the most inhospitable countries on Earth, Canada. And they had to dig for several years, only during the cold and short Canadian summer. But eventually they found exactly what they were looking for, and Jay was asking for, a transition in morphology between basostegocephalian fish like Eusthenopteron, and later more derived stem tetrapods like Ichthyostega.
This is like a missing link, a transitional form.
Well, it was missing when Gould wrote his book, but it's not now. But Eusthenopteron and Ichthyostega were found, and those were and are transitional forms. So really, Jay doesn't care how many transitional forms we find, because he can always jam his finger between any 2 of them and demand to know where the form between them is. And in many cases, the answer is we just don't have it. But if we find it, that won't mean there are no gaps. In fact, there will be 2 more. This is just the Dr. Banjo fallacy. But the fact is that special creation predicts that there should be no transitional forms linking distinct groups of organisms, and evolution predicts the opposite. So no matter how many gaps there are between transitional forms, even a single one of them is a good reason to accept evolution and reject at least a large degree of special creation. Jay knows this. He's just coping.
I was giving this very talk at a state university, and when I got to this slide, a student stood up and he said, "They found the missing link. It's Tiktaalik."
Oh, so he knows he's lying to people. It was already pretty obvious, but it's nice to know that for sure. Let's see if he goes full Banjo.
I said, "Thank you for mentioning that." And I clicked Tiktaalik. And I said, "Yep, they found Tiktaalik, the missing link, and it's proof of evolution." No.
And why not?
They found a fossil.
More than one, sure, and it's morphologically intermediate between Eusthenopteron and Ichthyostega. Exactly what was predicted, and it was where it was predicted to be.
That they had never seen before. They already had a lineup. So you look at a new fossil, where would this visually seem to fit? Oh, we'll put it there. Hey, we have proof of evolution. No.
Except that they didn't just stumble upon a convenient fossil. They predicted it must exist and what its morphology would be based on evolution. They predicted where they could find it based on evolutionary divergence times and standard dating techniques. And then they went out and they found it. That's not just coming across something and shoving it into a slot you happen to have for a transition. That's a confirmed prediction, which I'm told is the gold standard in science. How many times has someone used flood geology and special creation to predict the existence, location, and morphology of a heretofore unknown fossil organism, then gone and dug it up successfully? Near as I can tell, it's never.
It's just a creature you haven't seen before. It's already been disqualified.
What does it even mean for a creature to be disqualified? This isn't a horse race.
I don't have time to go into reasons why, but they know that no, it doesn't really qualify as a missing link.
Oh, the reason is fucking trust me, bro. Seegert. He has plenty of time. Once again, I'll remind everyone that this talk is an hour and a half long. That's plenty of time. Instead, he just hand waves away the very thing that devastates his argument that there is insufficient transitional fossils, and you know what? Just for that, here are more.
They just found it and put it in the lineup and told more stories.
Liar! Liar!
It's not proof of evolution, but doing something like that is not much different than doing something like this, talking about how an Etch-a-Sketch evolved into an iPad.
Oh man, except that just like with vehicles, Etch-a-Sketches and iPads have no genetic traits, have no inheritance from ancestors, and are all known to be made by people, while organisms do have genetic traits, inheritance from ancestors, and are known to be not made by people. I guess with the exception of new people, the vehicles are a poor analogy for evolution, because they have none of the characteristics needed to evolve in the first place. This is like comparing different sizes of sports balls, and then deciding that you can arrange them by size, like we do with stars, and then also saying that because none of them do nuclear fusion, therefore the sun doesn't either. It's so stupid, it's hard to believe anyone would do this in good faith.
These two things, these objects, don't look completely different. There are some similarities there. So use your imagination. What might it have looked like over millions of years in between? Maybe something like this. A little bit like one, a little bit like the other. But you know, there's no way the complex, or the simple workings of an Etch-a-Sketch could ever turn into a complex thing like an iPad on its own over time. It's not going to happen.
Right, because they're not things that reproduce with imperfect heritability and differential reproductive success. But fish are. So this argument means literally nothing. It has no bearing on anything to do with evolution, because it's not about things that can evolve according to evolution. Something that can evolve are humans, and most of my patrons are humans. If you too would like to be a patron who is probably, but not definitely human, at least as far as I know, then check the description for a link to my Patreon. It starts at just $1 a month, and you can get a 15% discount for pledging annually. You get access to my Discord, early access to videos like this, and you help support me. As of the time of my writing this, YouTube has been really rough, not just for me, but for many creators. I need your support to keep on going. So if you can afford it and you like what I do, please consider supporting me with just a few bucks a month.
Because of what would have to go on inside.
Yes, and what's going on inside either device doesn't include mechanisms for self-assembly or reproduction. Which means that this is a terrible analogy for life, which does include mechanisms for self-assembly and reproduction.
So, how do we make that transition from a single cell all the way to a human being?
Mutation, natural selection, and genetic drift, basically.
Well, when we reproduce, our kids don't look exactly like us.
That's true.
And that we can reproduce is a big difference between us and bikes or iPads.
There might be some similarities. They might end up having the same hair color and eye color, but they don't look identical to us. Changes occur. Changes do happen. And there are two types of changes. You have built-in variation and random mutation.
Built-in variation is just creationist for genetic diversity. But also the phrase random mutation, while not wrong, can be confusing. People often assume that random means uncaused, or that it means that all mutations have the same probability of occurring. Neither is true. Mutations are stochastic, in that humans cannot predict exactly when they will occur, nor can they predict where in the genome a particular mutation will happen, nor exactly what the mutation will be. Mutations are in fact caused by many things we know about, such as chemical interference in the replication mechanisms, radiation damaging the DNA, which then has to be repaired but is repaired incorrectly, etc. and some parts of the genome are more likely to mutate than others, and some mutations are more likely than others. So it's random like a random encounter table for a TTRPG is random. Some encounters are more likely than others, and how likely a random encounter is, in the first place, depends in part on where you are.
The built-in variation has to do with the genes in our DNA.
As if mutations don't?
We've studied DNA for quite a while, and we have a pretty good idea what these genes do.
Relatively speaking, yes, but we still have a lot to learn. You can tell because people keep publishing papers about it.
The random mutations, those are copying errors. Random copying errors.
Not always. That implies that mutation only occurs during replication of DNA. But that's not true. It can happen at any time. In fact, radiation is something that can cause mutations even in cells that rarely divide, like neurons.
We don't know what to expect with that because they're random.
Well, we don't know exactly what to expect, but we know what the range of possibilities is. Think about the random encounter table. If you're wandering through the woods, you're probably not going to encounter a giant scorpion or dark elves. On the other hand, if you're on a road, you'll most likely encounter merchants or bandits. And if you're in the desert, then thrycreen or scorpions may be likely. You can't be sure what will happen, but you're not clueless either.
Built-in variation. Here's an example. We have 2 medium-length furred dogs up here, and they each have 2 copies of a gene that makes fur length.
In real life, very few traits are controlled entirely by one gene. But for illustrative purposes, I think this is fine.
Why do they have 2 copies?
Because mammals are diploid, which means that they receive a full set of chromosomes from each parent, leaving them with 2 copies of each chromosome, each of which can have different alleles on them.
Because they got one from mom and one from dad.
Yep.
Each passed one on, so they got a copy from mom and dad, and they apparently have one gene that makes long fur, the L, and one that makes short fur, the S.
No, in this analogy, those would be the same gene but different alleles. If you don't know enough about evolution to explain it even at a basic level, which Jay clearly doesn't, then you don't know it well enough to criticize it. The first step to overturning any idea is to understand what you're overturning. No one is going to convince Seegert that his theology is wrong by arguing that Jesus can't have been the second person of the incarnation, because that's not how those words work. And just saying that demonstrates that the person who said it has no idea what Jay's theology even is at the most basic level. Similarly, if you mix up allele and gene, no one will take you seriously, at least not anyone who knows what you're talking about enough to assess it.
So those genes combined in their bodies, those dogs have medium-length fur.
Again, this would be alleles, but also this is an example of codominance, where 2 alleles result in an intermediate morphology. But many alleles are dominant or recessive, which honestly is a bit of a disappointment. Why couldn't it be dominant and submissive? Oh well. In a dominant recessive situation, then one allele is expressed while the other is not. So in this case, let's say that the way that the gene worked was by sending a hormonal signal to the hair follicles to keep growing hair, and that when the gene in question is deactivated, the follicles stop. The 2 alleles differ in how long they send this signal. In this case, since the short signal would stop early, but the long signal would keep going, we can say that the long hair would be dominant, since the signal would keep going regardless of the presence of a short hair allele. In this case, only if 2 short hair alleles were present would we get a short-haired dog. And there would be no medium hair condition. Now, this is all hypothetical and not how it really works in dogs. It's also not the situation that Jay is describing. I just wanted a chance to explain genetics in a bit more depth than Jay even can.
If you breed these 2 dogs, they will each pass on one of those 2 genes.
Alleles.
They don't get to pick and choose, I think I'll do this one. No, just one goes or the other. If they both pass on a gene for short fur, the puppy will come out with short fur. It doesn't have an option. It doesn't matter which of those 2 genes gets expressed in its body, or even if those genes would combine, it's going to have short fur. If they both pass on a gene for long fur, the puppy comes out with long fur. If one passes on a gene for long fur, the other for short, the puppy can come out with long fur, short fur, or medium length fur if they combine.
No, it's going to be medium if the alleles are codominant, long if the long hair allele is dominant, and short if the short hair allele is dominant. Traits don't just get to pick which genotype they care about.
Genes don't just do fur length, they do other things too. Give us big dogs, little dogs, long ears, short ears. All the features we see on dogs, they're pre-coded in the genes. We know how that works.
Wow. Biodeterminism much? In fact, it's not the case that everything about an organism is determined by its genes, although a lot of it is. I have 2 uncles who are identical twins in my adoptive human family. They are not identical. One is heavier than the other, one has more teeth than the other, and one even has developed a mild form of autoimmune disorder, which the other has not. Similarly, if you look at a grove of aspen trees, they are usually all clones of each other with connected roots, yet each trunk is unique and has its own unique pattern of branches. Environment also plays a key role in determining what an organism will be like. For example, in mammals, things like lack of nourishment of the mother during pregnancy or nursing can cause birth defects or growth problems, as can malnutrition during juvenile stages. Living at higher altitudes results in larger lung capacity and more red blood cells, and this can change even as an adult. Genes aren't destiny. They're part of the board on which the game of an organism's life is played. But the moves on that board also matter.
Now, if you look at these two sets of animals, set A and B.
Okay, so set A is dog, dingo, coyote, and wolf. So 3 members of Canis lupus and 1 member of Coelatrans. Then we have a lemur, a crab, an armadillo, and an iguana. Specifically, we have a ring-tailed lemur, Lemur cauda, a fiddler crab, which given how many species there are and how poor the image is, I can't identify down to the species, but I suspect it's a member of the genus Ostruca, a 9-banded armadillo, Dasypus novemcinctus, and a green iguana, iguana. Got it. So Group A is all members of the same genus, and Group B is a bunch of bilaterians, most of which are amniotes, and half of which are therian mammals. Do you think he'll point out that because Group A is very similar, it's easy to think of them related, which is not as true for Group B? I think that's where he's going. Of course, the first thing to point out, in this case, is that what's easy for someone to imagine isn't relevant in science, since much of science seems impossible to imagine anyway. Like quantum mechanics. That doesn't stop it from working.
Which set of animals looks more like each other? It's pretty obvious. Animals in set A look a lot more like each other than those in set B.
Well, yeah, most of them are in the same species, and the one that isn't is in a sister species. The most recent common ancestor of Group A lived about 2.39 million years ago. The most recent common ancestor of B lived about 686 million years ago. That's more than 100 million years before the start of the Cambrian. Of course Group B looks very different to each other. If we take just the amniotes, the lemur, armadillo, and iguana, then the most recent common ancestor of that group lived 319 million years ago, during the Carboniferous period. For the most closely related animals in Group B, the lemur and the armadillo, their most recent common ancestor lived about 99 million years ago, in the Albian stage of the early Cretaceous. So the most related of Group B are more than 40 times more distantly related in terms of time to most recent common ancestor than the most distantly related members of Group A.
And why is that?
Well, the proximate reason is that J. Seegert handpicked these groups to illustrate what is almost certainly going to be a very stupid point. But the ultimate reason is that the farther back in time two organisms share a most recent common ancestor, the more different they are likely to look.
Because they're the same kind of animal.
But what does that mean? Does it mean animals that share a most recent common ancestor less than 3 million years ago? Does it mean animals that all look like the same approximate degree of good boy? What makes lemurs and the armadillo not the same kind? Or the armadillo and the iguana? Or even the lemur and the crab? They all share common ancestry according to every test we can devise that could test such a thing.
Genesis 10 times in the first chapter says God created creatures to reproduce after their kind.
Okay, but so what? That doesn't tell me what a kind is, or what I can use to determine if a change in kinds has occurred or if it hasn't. Further, evolution isn't about changing into something that isn't what a species was before, but about adding diversity on top of the existing lineage in a branching pattern. As long as we simplify just a bit to leave out horizontal gene transfer. One organism gives rise to descendants who themselves are the same thing but with variation on top of that. It's really like a tree growing. You can always trace an organism or twig back to the main trunk through an unbroken series of branching events.
Yeah, they can do a variety, but always within distinct limits after their kind.
But no one has ever proposed a limit for this. If there is a definition for kind that involves such a limit, then there must be some kinds of mutation that would bring an organism outside of the kind. What mechanism prevents such mutations? I'm not aware of one that has been proposed, never mind one that has been demonstrated. If instead all kind means is a group of organisms that share a common ancestor with each other, but not with any other organisms, then evolution simply says that change between kinds is indeed impossible, and that the total number of kinds on Earth seems to be 1. Which means that the change from the first bilaterian to both the first fiddler crab and the first lemur was not a change of kind, just a change within a kind. In other words, for some definitions of kind, we know that organisms can and do change kinds. For other definitions of kind, evolution doesn't involve a change of kind. So the whole kind argument fails any way you look at it. And of course, creationists are loath to say which way it should be looked at. Probably because they either can't understand the problem, or they're smart enough to realize that there is no definition of kind which is both testable and that poses a problem for science.
In fact, you can breed dogs, dingoes, coyotes, and wolves. They can all breed together.
And they can breed with New World canids, like the crab-eating fox. But can they breed with does or Old World foxes? Nope. But do you really think that he'll say that this animal and this animal aren't in the same kind? I think he'd reflexively put them in the same kind. Even though, as near as we can tell, they can't breed. Further, do you think he'd put this animal and this animal in the same kind? Because at least in laboratory settings, humans have created human-hamster hybrids. Granted, they don't live long, only a few hours at maximum, and that's after fertilization, not birth, but still, they lived. They were individual animals that were a hybrid of human and hamster. If we use the ability to reproduce as our demarcation for kinds, things are going to get really weird really fast.
Look at them. Do they look like completely different creatures? No, they're very similar creatures. So you can breed a dog and a wolf, and you get a wolf dog.
Well, those are members of the same species, so I'm not sure why that would be surprising. But also, creationists tend not to accept species-level creation. They tend to favor going to the arbitrarily defined family level, which doesn't make any sense since family, again, doesn't actually mean anything objective, but whatever, they do it anyway. So no model for common ancestry, whether creationist or scientific, is tested by breeding members of the same species. The dingo is also part of the same species.
That's not a surprise. It looks a little bit like the dog, a little bit like the wolf.
It's not a surprise in the same way it's not a surprise if you find a couple of humans, one a male from Norway and one a female from Indonesia, and find that they can have a baby who will look a little bit Norwegian and a little bit Indonesian. Members of the same species can breed together. If that isn't true, then you're probably dealing with more than one species, although closely related species can also interbreed too. The only reason it doesn't really happen in humans is that there are not terribly closely related species to humans. Humans' closest relatives are chimpanzees and bonobos, and they're separated by humans by more than double the time separating coyotes and wolves. Also, who wants to try? Certainly not the humans I know. One group of humans that I can guarantee aren't doing unethical human hybridization studies are my channel members. Right below this video, you can find a join button. Joining the channel as a member gets you access to my super secret Discord server, early access to videos, a channel badge and a green name in livestream chats, and access to channel emojis for use in chat. It starts at just $1.99 a month.
This is what we expect from genetics, and this is what Scripture tells us to expect.
Actually, Scripture doesn't really help here, even if we assume it's the Word of God, because Scripture doesn't say what a kind is. So we have no way to use Scripture to predict what organisms can reproduce with what other organisms, and if you just want to say that things that can breed are related, well, evolution doesn't disagree there.
But you can't breed a wolf and a dog and get an ostrich.
Right, because that's an entirely separate species, a dinosaur in fact. Evolution doesn't proceed by breeding together members of the same species to produce a member of a completely separate existing species.
Why? Because they don't have genetic information to make beaks and feathers.
I still don't know what that means. They certainly don't have genes that will do that, but is information just the number of genes and their functions? If that's the case, then fun fact, we can see new genetic information come into being both in the past and in the present day.
So you can get a variety, but it's always going to be within limits.
So the limit is that you can't evolve into a species that already exists in some separate clade. Okay, that's not a challenge to evolution. Evolution says that brand new species come along and remain members of each clade their ancestors belong to. Just like the branching tree. Jay is imagining that evolution proceeds by a branch occasionally just jumping to a new location on the tree and severing its previous connections. That's a violation of the basic principles of not just evolution, but ancestry.
You can also breed a zebra and a donkey, and you get a zonkey. It sounds kind of funny, but this is real life, real science. Why, are those two creatures completely different? No, they're basically the same, but one has a nice paint job.
Okay.
He goes on to say the same thing about lions and tigers. I'm skipping any subsequent such examples. We're all aware that closely related species can reproduce. That's something that is not a way to distinguish between evolution and special creation, since both would expect this to be true.
But you can't breed a lion and a kangaroo to get a lion-garoo. That one's not going to happen because they're not the same creature.
Yes, as genetic pools stay separate over time, they develop differences that limit and eventually preclude reproduction between members of different pools. This is standard evolutionary biology. So while this is technically a new point, we are once again just saying things that are not in any way contradictory to the theory of evolution. Like when Jay imagines a biologist, does he think that they haven't noticed that not all organisms can breed with each other? I promise, they have indeed noticed that.
You can't breed creatures that are not the same kind.
So if they can't breed, they're not the same kind? If that's the claim he wants to go with, then that's fine. But it means that we have indeed seen new kinds come into being. Heck, taking fruit flies and feeding them different diets for a few years is enough in some cases to make flies that can't breed with each other. By this definition, you can create new kinds in your own house with some fruit flies, a few different kinds of feed, and some habitats for the flies. Somehow, I feel like if it's the kind of thing that an untrained person can do in their spare room in the space of less than a decade, then it's probably not a barrier for evolution. But also, as I pointed out with canids, creationists don't actually use this definition. It splits up animals they want to combine, like the canines. What they actually say is that sometimes members of the same kind can breed, but sometimes they can't, and members of different kinds never can. This makes the whole thing unfalsifiable, and thereby not scientific. We can't use reproduction to answer the question, are organisms A and B in the same kind, with a no. All we can say is yes or maybe. That's textbook unfalsifiability.
So that was the built-in variation. Now we're going to take a look at the random mutation, these accidental copying errors in the DNA.
Of course, the thing there is that built-in variation is actually just mutations in the past. Seriously, how would you distinguish a mutation that happened, say, 3,000 years ago, so after the alleged flood, from a genetic variation put there by God? Well, just from looking at the genetics of a single individual, you can't. But interestingly, we actually can at a population level. You see, you can use a wide sampling of a population to determine how long ago a region of the genome was the same for the whole population. In other words, not only does the population as a whole have a most recent common ancestor, but so does each part of the genome. And it's not the same. This is how we figure out things like mitochondrial and Y haplogroups. But it works for any part of the genome. It's just more complex math for the other parts, because those parts recombine. Creationists broadly accept this idea, since they themselves use it to try to trace out the descendants from Noah via things like Y chromosome haplogroups. So if a bunch of genetic diversity was built in at the start, and instead of calculating the time to the most recent common ancestor, we trace it back to the most recent 4 common ancestors, since at least for animals, according to the Bible, 2 haploid individuals got on the ark, then we should get most of the genome coming to the same value for time to most recent 4 ancestors. We don't, though. Which means that this idea of initial diversity created by God has no evidence, and everything we see is exactly what we would expect if all genetic diversity arises from mutations. It also helps that we can see examples of mutation in the wild and in the lab, and we cannot see examples of divine creation of genetic diversity in either setting.
We are now magically transformed from a church into a state university. Biology classroom, and I am the PhD biology professor, and I'm going to teach you how evolution works.
I want to read you the entirety of Jay Seegert's bio from his own ministry website. Keynote speaker and managing director for the Starting Point Project, thestartingpointproject.com. International speaker and author, holds degrees in both physics and engineering technology, University of Wisconsin-Whitewater and John Brown University. President of Logos Research Associates, speaker for the Creation Science Association of Fiji. Representative speaker for Ratio Christi. Former adjunct speaker for Creation Ministries International. Former president of Creation Science Society of Milwaukee. He's been speaking publicly on the authority of Scripture for over 40 years. Married 32 years, wife Amy, 2 married children, son Taylor, daughter Tori. Lives in Wisconsin, USA. You know what none of that says? That's right, that he has any education in biology at all past the high school level. And it certainly doesn't say that he's a PhD in biology. And if he did have a PhD in biology, I can't imagine that they wouldn't put it out there at the top of his bio bulletin list.
So you have an organism here.
Since that's a virus, that depends on who you ask, but let's pretend it's a cell.
And it's going to reproduce. So it copies its DNA and it makes children.
So far, so good.
The children look pretty much like the parents because it's a copy of the same DNA. The children reproduce and make grandchildren, which look pretty much like the parents and the grandparents because, again, it's a copy of the same DNA. Then the grandchildren reproduce and, we got some significant mutations going on here.
Mutations occur at every copying event. But I don't know what he means by significant, but I'll just assume that by significant mutation, he means a mutation with enough of a fitness effect that selection can act to either preserve or remove it, which itself is going to be dependent on effective population size, but that's probably getting too far into the weeds.
Apparently some of them are bad and some are good.
Yes, that is apparent, because we can actually measure fitness effects. The fitness of an organism is a measure of how much its genetics contribute to the future generations. It can be measured in a few ways, but I like measuring it as the number of grandchildren that reproduce. So it's apparent in the same way that the fact that children grow is apparent, or that water flows downhill is apparent, or that stars have different spectra is apparent. Some mutations make an organism more likely to have descendants or have more descendants, and some make an organism less likely to have descendants or have fewer descendants. Most mutations do neither, though.
But then natural selection comes along like a superhero and wipes out those bad changes. It just keeps the good ones.
Just using a condescending tone doesn't make the mathematical inevitability of natural selection go away. In fact, it's so inevitable that young Earth creationists don't generally dispute it.
And now the new good organisms, they continue to reproduce, make more of the new ones, and the original ones continue to reproduce and make more of those. And that process continues on for millions and millions and millions of years.
Billions, actually.
Can you imagine the great variety of creatures we would have on this planet through a process like that?
I don't have to imagine it. I'm part of it. So are you watching, and so is every organism you've ever seen or interacted with in any way. That bacteria that caused your strep throat, that's part of it. That yeast that makes your bread rise or that turns sugar into the alcohol you drink, it's part of it. Your adorable pet is part of it. The birds outside are part of it. The trees in the forest are part of it. Literally, the life on Earth is the result of that process. That's kind of the point.
Now, I guarantee you the non-Christian students sitting in a classroom hearing that, they say to themselves, you can't argue with that.
You can argue with anything. The question is, can you do so in a way that actually indicates that it's not true, and that some other idea is true? The answer to that question is no. Whether you're a Christian student or anyone else, student or not, Christian or not. And I have to reiterate for the billionth time that Christians are not all, or as far as I can tell, even majority, evolution deniers. J. Seegert doesn't speak for all Christians. He doesn't have some special revelation about the Bible. He's just some asshole who's wrong about science and is at the very best carrying water for Christofascists.
I mean, this is my PhD biology professor. He knows what he's talking about. This is science. This is facts. This is not that mythical Bible stuff. That's what the non-Christians conclude. Guess what? Most of the Christians conclude the same thing.
Most Christians are reasonably intelligent people who are capable of receiving new information and altering at least some of their views based on that new information. That's good to hear.
Because it makes sense. I mean, you can't argue about it. This is science. I mean, this is like true stuff where the Bible is more of a touchy-feely thing and it can be whatever you want, right?
Any text can be whatever you want within certain limits. But what the Bible can't be is a completely accurate telling of the past, because we know it's wrong about a lot of stuff if you take it literally about those past events. There never was a Garden of Eden. There never was a global flood. There never was a Tower of Babel. There never was a Moses, at least as depicted in the Torah. There never was a conquest of Canaan by the Israelites. There never was a unified Israelite kingdom before the Babylonian exile. Basically, until the Babylonian exile, more or less everything the Bible says about history varies from conclusively known to be wrong to mostly wrong, but with some bits that are probably correct, such as the bare existence of some characters, or some of the later wars.
So they go with this.
Cool, they go with science when considering topics that are studied by science. That is the best option you can take.
And they usually end up walking away from their faith. Why do they even need the Bible at all anymore if science can tell you truth?
Neither my area nor my problem.
We are now going to take a closer look at mutations, and we're going to do what Paul Harvey used to do and look at the rest of the story.
Paul Harvey was an American radio broadcaster who died in 2009 and was most famous for his weekday broadcast, The Rest of the Story. In later years, his son also hosted the show, and it ended in 2009 with Paul Harvey Sr.'s death.
Can mutations actually do what they tell us? And you're going to find out, ain't no way.
Boy, was I wrong.
I'm going to make 3 major points about mutations. First of all, they're random, purposeless, and undirected.
Yes, as long as we remember that random doesn't mean uncaused or equal probable. It seems like a silly thing to have to say, but creationists have been known to use things like the existence of mutation hotspots in the genome to pretend that mutations are not random, and from there to say that they are in fact purposeful or directed, either by the organism itself or by God.
They're occurring in the DNA, and they're almost all detrimental or bad.
No, they're almost all completely neutral, for a few reasons. First, since most of the genome is non-functional, a mutation is fantastically unlikely to affect fitness at all. Since most will occur in junk regions, although it's not impossible for such a mutation to have an effect. Second, even mutations in the functional parts of the genome are likely to be neutral, since many sequences are identical in terms of protein coding or regulatory activity. Second, some mutations are just whole gene duplications. Those are at worst going to overproduce some protein, but since the new gene may not even have a promoter, it will also likely do nothing. But of the mutations that do cause some change, more of them are going to be harmful than helpful, just because there are more ways to be bad at something than there are to be good at something, even when that thing is reproduction. Just ask the incels.
Number one, they're random and purposeless, basically. Here's a quote from Nova Online. This is a secular source talking about mutations. It's sometimes convenient when trying to make sense of evolution to think of changes within a species as having a purpose, as though Mother Nature has some intended goal that she sets out to achieve. The bacteria want to survive, someone might reason when thinking about the declining effects of antibiotics, and so they evolve into resistant strains. Of course, there is no purpose in evolution, just random mutations within DNA, most of which are detrimental to the survivability of the organism.
Other than getting the last bit about most mutations being harmful wrong, yeah, Nova is right. In fact, we've known this for over 80 years, and with almost his exact example, bacterial resistance. An experiment called the Luria-Delbruck experiment demonstrated how all this works. The experiment was specifically designed to see whether mutations are the result of organisms responding to environmental changes, or if they were simply random. The experiment used resistance to bacteriophages, viruses that attack bacteria. If mutations are the result of environmental stimuli, we should expect that different groups of bacteria of the same species would all develop resistance to the same bacteriophage in the same concentrations at the same rate. After all, they're all nearly identical and exposed to the same environmental conditions. And before they are, there's no real particular reason to expect them to have mutations granting them resistance to such things if they are actually deterministic responses to the environment. So we should expect all the colonies to behave about the same in terms of resistance development. Turns out, this is not what happened. Some colonies were nearly immune from the onset. Others only gained resistance as the experiment progressed, and some never actually developed resistance. This means that mutation-granting resistance arose before the experiment in some bacteria, during it in others, and never in yet others. This tells us that those types of mutations happen essentially at random and are not tied to an environment in which they might be useful. Let's take Jay's favorite group of animals as an illustration. Some fennec fox is just as likely to have a mutation that would make it well adapted to a human forest as it is to have a mutation that makes it better suited to its desert environment. But that's just how it is. And if that fox were lucky enough to end up somehow in such a forest against all odds, then hooray for it. It will be selected for over its kin that lacks such a mutation. But none of them will get the mutation in advance because they know they're off to a humid forest. And similarly, after getting there, their offspring are no more likely to get mutations benefiting them in that environment they would have been while still in the desert. In other words, we know for a fact that adaptation arises from changes in genetics, that such changes happen as a result of mutation, and that such mutations are not predetermined or caused by the environment, but rather they are stochastic.
But then you look at the popular literature like Discover News talking about dinosaurs. Presumably, the sauropods evolved large body size as a strategy to deter predators.
Yeah, because while mutations are random, selection is not. So if a population has predation as a major source of lack of reproductive success, then mutations that help relieve that pressure will be favored, even though they arose for no particular reason and with no purpose. That's how evolution works at the most basic level.
Well, what are they saying?
They're saying that natural selection works, something that creationists broadly agree with.
It's something like this. Apparently, at some point in the past, dinosaurs weren't as large as they eventually came to be.
Well, we're talking about sauropods in particular, and we know that to be the case. We can look at animals like Plateosaurus and Saturnalia, which are prosauropods. Saturnalia is about as big as a raven, and Plateosaurus is about as big as a camel. Then we can look at early true sauropods like Volcanodon, which was about as big as an elephant. Then later sauropods like Apatosaurus that was over 8 meters tall at the back and even taller if it raised its head. Finally, we can see sauropods like Argentinosaurus, which was probably the tallest and heaviest land animal to ever live. Not all dinosaur groups are characterized by increasing size through time, but prosauropods, which include the true sauropods, certainly are.
So they're sitting around the fire one night and they're saying, hey, you guys, we need to come up with a strategy to deter our predators or we're going to go extinct much sooner than we're supposed to.
Nope, they're just living their lives, eating, pooping, breeding, and getting eaten. Sometimes, some of their offspring have a mutation that makes them a bit bigger, and not worse at eating or breeding, but better at not getting eaten. Those ones have more offspring than the smaller ones, and the average size of the population goes up. And as long as getting bigger remains an advantage, then it'll keep happening that every once in a while, for no particular reason, a mutation will happen that results in a larger individual, and that mutation will be selected for. Once again, explaining science in a mocking manner doesn't actually make science wrong.
You have any ideas? And they say, no, our brains are too small. And then one of them says, I got an idea. What if, when our predators come after us, we get some machine guns out, we could shoot them?
I can't even imagine what the point of this is, so I'm going to skip until an actual point is made. We all know that he'll just pretend one of them decides to get bigger.
There's not a scientist on this planet who believes that.
Right, which is why when Jay brings it up, it makes him look like a moron, or a liar, or both.
An atheistic evolutionist does not believe that scenario.
Neither does a non-science denying Christian. We all know.
They don't believe creatures decided they needed something, so they evolved it. But the popular literature will give you that impression.
It will only give you that impression if you don't know what you're reading and can't think. I suspect that Jay does know what he's reading and can think, and so knows better. I am finding it rather impossible to think that Jay is arguing in good faith here. The solution to this problem he thinks exists is just the very basic fact that while mutations are random, selection is not. Something that is usually taught in high school, the high schools that he's worried about.
Like the fish. You see, they were swimming around in the oceans for millions of years, but food started to become scarce, so they needed to evolve lungs to get up onto land to find new sources of food.
Nope, lungs had already evolved before any fish started moving onto land. They started as simple extensions of the gut, and then because the gut can absorb oxygen and the air has more of it than the water, and fish today, even without lungs, still swallow air to help in low oxygen environments, the lungs that had mutations to make air-based oxygen intake more efficient were selected for. It turns out that most fish today are descended from fish that found it was even more helpful to be able to control their buoyancy, and so mutations that fill the lungs with a fluid and cut them off from the rest of the digestive tract resulted in swim bladders in modern teleost fish. But lungfish and tetrapod fish, like you listening, and like Jay, retain their ancestral lungs, whereas fish like carp are back to gulping air into their stomachs if they need supplemental oxygen.
So they evolve lungs. Guess what the students do in that class? They write that down. Because that's what the professor just said.
No, they don't, because the professor didn't say that. The professor got it right, that, as often happens in evolution, a structure that evolved as a result of one pressure also pre-adapted a group of organisms to exploit a new niche. And so eventually they filled that niche. It also happened with dinosaurs and feathers. They initially seemed to have evolved for thermoregulation and display, but they also inescapably had aerodynamic properties, and so some dinosaurs used them to fly. We call those dinosaurs birds.
I mean, these fish, they got to do something or they're going to go extinct.
I have no clue what he's talking about. Organisms don't radiate into new niches to avoid extinction. They do it because a niche being available is the same thing as there being resources available that are not currently being used. And any mutation that allows an organism to exploit previously unexploited resources is a huge fitness boost. There doesn't need to be any pressure of extinction. In fact, in the paleontological record, it tends to be after extinction events have passed that we see significant radiations. That is, after species are no longer in huge imminent danger of extinction. So if anything, pressure that threatens extinction may actually retard radiations in evolution. Although I don't know of any studies saying that, so I wouldn't bet money on it.
Wait a minute. How do fish know what lungs are?
They don't. Well, I mean, some do. Jay's a fish, and he knows what they are. I'm a fish, and I know what they are. You listening are presumably a fish, and I suspect you know what they are. But most fish don't know what they are.
I know they swim around in schools, but I mean, how would they know?
Yep, they don't. Fish are mostly pretty dumb. Even compared to Jay Seegert. Of course, there's no reason to think fish ever needed to know what a lung is to have one or to evolve one. Because evolution isn't something that occurs as a result of the conscious choice of individuals outside of artificial selection. And I don't think anyone is proposing millions of years worth of artificial selection in fish to explain lungs.
They wouldn't even know what a lung is, even if they knew. What are they going to do about it?
What are they going to do about what? Lungs? Nothing, except use them when they have them.
They only have genetic information to make fish parts.
Good thing lungs are fish parts, I guess. Although, again, new information arises all the time in genomes, and unless Jay is going to give us his definition, then I have to go with definitions I'm aware of and can test. The main ones would be just the nucleotide sequence and chromosome divisions as a whole, the number of genes, or the total nucleotide sequence and chromosomal arrangement of just the functional parts of DNA. Under any of these definitions, genetic information can be observed increasing in real time, and even in one of his favorite examples, dogs, we see obvious and undeniable increases in genetic information compared to wolves under these definitions.
And even if somehow, when they're reproducing, they're making random copying errors, what do they do when they're somewhere in the middle? They can't breathe underwater anymore, but they can't get up on land and breathe air yet.
That isn't ever a thing that happened. Lungs are an extension of the gut, but gills are not. That's why you can have both, as in both African and South American lungfish. a real living thing that currently exists and has both gills and lungs. Now, it can't spend all of its time on land, but that's not because it runs out of oxygen, it's because it runs out of water. Gills are structures that form from the embryonic pharyngeal arches, like your jaws, which are in fact modified gill arches. Lungs are just an extension of the digestive tract, which is why you can choke. Because of the evolutionary history of lungs, they remain connected directly to your gut, meaning you can choke and inhale water and other such unfortunate things. Terrible design, but since evolution is just stumbling around in the dark with no foresight, that's what you'd expect from evolution. But because gills and lungs form from completely different parts of the body, their development doesn't interfere with each other, and you can have both fully functioning lungs and fully functioning gills in the same animal, which again, we do right now on this planet.
Dad, it's not going to work that way.
Yeah, which is why no one thinks it did, and that's not what the fossil evidence indicates either.
But that's what's taught in the textbooks. You just have to imagine how the fish acquired lungs, and this, they evolved. They use these phrases. They acquired this, they got that, they developed this. Like, how?
That's also explained in the textbook, but it's mutations ultimately, which can mix together faster in diploid organisms through recombination, which happens as part of the process of sexual reproduction. For how much Jay complains about what's in textbooks, he seems to have never really bothered to read any of them, because this is all explained in them. Maybe he's only reading textbooks for babies and needs to graduate to some undergrad level texts. I don't know.
How do they acquire lungs?
The gut already absorbs oxygen because absorbing things is sort of what it does. An extension of this is a matter of a relatively small mutation to regulatory genes that are active in embryonic development. This means increased surface area for the gut, which means increased surface area for oxygen absorption. Because fish sometimes find themselves in low oxygen water, they gulp air. Those with this extra pocket extending from the digestive tract now are better at getting that oxygen. Boom, lungs. Granted, rudimentary lungs, but that's how evolution works. New structures are always both rudimentary and simple modifications of previous structures.
When they talk about the details are absent.
I feel like I'm being pretty detailed. I don't know off the top of my head of the exact genes involved, but I could probably look it up. Is it that scientists and science communicators aren't being detailed? Or is it more that Jay just isn't looking into it? I mean, I could say right now that quantum chromodynamics is dumb because you can't have color at that scale, and no one has explained it to me in detail. But I suspect that if I actually wanted the detail, I could get it. Because chances are that the actual scientists who study this have in fact gone into great detail, and I just haven't exposed myself to that. Because frankly, I don't really care to. In Jay's case, it's more that he's scared to, because he wants to be right about his theology. Reality be damned.
So, that was the fact that their purpose is random. Now we're going to talk about DNA very briefly here, that these mutations are happening in the DNA. So let's temporarily talk about storage capacity of DNA.
Okay.
Imagine you're holding a teaspoon from your kitchen.
Sure, I held one earlier today when I was stirring my coffee, so this should be easy.
And it's filled with your DNA.
Well, that's a weird thought, especially since a teaspoon is the upper end of the normal volume of ejaculate for a human male. Fun facts with Dapper.
How much information could you fit in a teaspoon's amount of DNA?
Enough to make one human baby, or I guess half as much?
Well, we back up our computers, right, in case they crash. So let's say you want to back up a teaspoon amount of your DNA. Well, let's say you want to put it on a 64 gig thumb drive. 64 gigs pretty big for a thumb drive. You could fit almost 1 million pages of information on a 64 gig thumb drive. That's a lot of space. A lot of information could be stored there. So how much of that thumb drive would be filled up from just a teaspoon amount of your DNA?
About 1.25%, or practically none of it.
Well, it would fill that whole thumb drive up.
No, it wouldn't, since the human genome is about 3.2 billion base pairs long. Since each base pair can have one of 4 variations, it takes 2 bits to encode each one in plain binary. That means it takes 6.4 billion bits to record a single human genome. That's the same as 800 megabytes. Since every cell in your body is going to have a basically identical copy of your DNA, the only thing going on in a teaspoon of it is that you have the same DNA over and over and over again. A single backup on a single medium is just as good as a bunch of them on the same physical device. So you could fit your genome onto a 64 gig thumb drive about 40 times or so, given that you're actually a diploid and 3.2 billion is the haploid number. Far more than the one time that you would need to.
In fact, you'd need more than one thumb drive. How many would you need? 1,000? Wow, that would be really impressive. It's not true.
In fact, it's not true because you'd need less than one. But also, if you have big number, therefore God on your bingo card, make sure you check it off. I'm skipping the next bit where he keeps giving bigger and bigger numbers. Eventually, he lands on the number 50,735,000,000.
Oh, but that all happened by accident. Particles were banging together over history, and we got DNA. My faith isn't strong enough to believe that one.
Well, since particles banging around is about as good an explanation for evolution as some Jews moving their mouths a long time ago is for Christianity, it's fine that he doesn't believe that. Evolution isn't that hard to figure out. If you have something that has some storage structure for instructions that dictate how it interacts with its environment to a significant degree, and that thing can produce copies of itself, but with changes to that structure, and those changes can affect how many copies get to be made, then evolution is mathematically inevitable. Living things meet these criteria, but so too do the subjects of genetic algorithms in computers. Computers actually design things, including code with evolution. NASA has evolved its own radio antenna for Jupiter missions that minimizes interference from the intense radiation that Jupiter gives off.
The DNA is like the coiled up ladder, you know that. It's like a set of encyclopedias, and if you're under 20 years old, that's what encyclopedias look like. They're like books. I don't know if you heard a book or not.
Well, now we're at 4 similes for DNA. I wonder if we'll add in computer program too, so that we can have 5 similes.
So, DNA is like a set of encyclopedia, and the rungs, those are called nucleotides. So the rungs on the ladder are called nucleotides. It's like a single letter out of that whole set of encyclopedias.
Almost. The full rung, as he calls it, is actually a nucleotide base pair. The nucleotides are only half of the rung. He's doing better than Kent Hovind, though, who thought each rung was a gene.
And if you put a whole bunch of rungs together, a whole bunch of letters together, that's how you make words.
I suppose in this analogy, words are genes, which, sure, I guess so. It's not the worst analogy out there.
And if you put thousands of these rungs or nucleotides together, that's how you make a chapter in the set of encyclopedias. And a chapter is equivalent to like what we would call a gene, the genes that you have in your DNA.
Yeah, I guess. I got how he's mapping this onto an encyclopedia wrong, but in my defense, that's in part because encyclopedias don't have chapters, they have entries.
And then if you put thousands of genes or thousands of chapters together, that's how you get a single volume, one of the books of that whole set, which is also what we call a chromosome.
I actually think that the chromosome to volume comparison is decent, although it's worth noting that chromosomes can vary wildly in size and content, which is not so much true for encyclopedia volumes.
And then when you look at the entire genome, all of the DNA, that's like the entire set of encyclopedias. For humans, we call it the human genome.
So what's the point of all this?
That's a little biology 101. Many of you probably already knew that already, but just some basic stuff.
I'm going to go out on a limb and say that virtually everyone in my audience not only already knew this, but currently knows it better than J. Seegert does.
So, again, here's the story of evolution. Let's say you had a biochemistry textbook. It's very technical. It's got a lot of information in it. The amount of information in a single-celled organism is about equivalent to an entire biochemistry textbook.
That depends. Different single-celled organisms can have wildly different sized genomes. The organism with the smallest known genome is Mycoplasma genitalium, which is a parasitic bacterium that infects humans in their urinary tracts and genitals. Its genome is at most about 590 kilobases, or 147.5 kilobytes. On the other hand, Polychaos dubium, a relative of amoebas, has a genome of 670 billion base pairs, taking up 167.5 gigabytes. But hey, what's 6 orders of magnitude among friends, right? Interestingly, creationists are often wrong by 5 to 7 orders of magnitude. So this is a nice little coincidence.
So there are no simple cells.
Well, that's relative, but also no cell today is the same as the first cell. Every single cell today is the product of over 3 billion years of evolution. We can't really just assume that the simplest modern cell is a good analog for the first cellular life.
That's a lot of information in that single cell there, but remember, we need to turn that cell all the way into a human being.
Oh, an organism that has far less information than many single-celled organisms? Doesn't seem too bad.
Human beings are much more complex than a single cell.
Are they, though? It seems intuitively true, but intuition is basically useless in science. Do we have a way to quantify complexity and then show that humans have some particular level of it? While P. dubium has a lower level? Not that I'm aware of, But it would be interesting if Jay has such a thing.
So how do you do that?
It's still drift, mutation, and selection, like the last time he asked this stupid question.
Well, here's a book that was produced from the Bioinformatics Symposium at Cornell. They put all the papers together and produced a book. Here's one of the pages. Don't worry about reading all that right now, but I've highlighted a certain section. I'm going to put that off to the side here.
Oh good, Jay has been toiling away in the quote mines and has hit a gemstone.
If we had this book and we copied that book over and over and over, millions of years from now, we would just have a lot of that book.
Setting aside the problems inherent in continuing any human activity for thousands of years, never mind millions of years, sure, I guess so.
It wouldn't be anything else. It would be that book, lots of copies. If we want to take that book and make it much better and more complex, we can't just copy it. We'd have to make some changes. Well, what changes are available to evolution?
Pretty much anything compatible with physics.
The mutations we've been talking about. Mutations are these accidental copying errors. Oops, oops, oops. So let's take a look at what a copying error looks like. The first one is called a duplication error.
And now we start looking at the genome/book analogy at such a granular level on the book side that any validity to the analogy has long since broken down. Genomes aren't books, and mapping different kinds of mutations onto different kinds of scribal errors won't tell you anything useful about either mutations or books.
A duplication mutation. So I took the word level up there and I added an extra L at the end. It doesn't spell level anymore.
It kinda does, though. Like, no one reading that book who is fluent in English is going to be confused by that misspelling. The only reason anyone thinks of it as wrong is because dictionaries decided to arbitrarily decide on so-called correct spellings, and people just kinda let them. But there's nothing about either English as a language or about reality itself that dictates that the word level must be spelled with 2 rather than 3 L's. But DNA doesn't have any dictionary telling it what it's supposed to say. It's just chemistry, and some mutations, including duplications, don't really change anything much. A single nucleotide duplication, which is really just an insertion, can change a reading frame and result in a whole new protein, or the lack of one, but a whole genome or whole gene duplication can result in no change except providing the material for future mutations without loss of function as a result of redundant genes. That's not something that really happens in text, which is why text is a poor analogy. Also, in general, texts are designed so that they are supposed to be read in the order in which they appear from front to back. But a genome isn't like that. Genes aren't arranged in a particularly important order, and genes frequently migrate from one section of the genome to another to no ill effect on the organism. That can't happen in a book, which again is another reason that this analogy is stupid when you follow it down to this level of detail. Like all analogies, eventually this one breaks if you take it too far, and Jay loves to take analogies too far in order to say that science is wrong, when in fact it's just his analogy that is wrong.
Now, I know what you're thinking. If you were reading that, you'd think, well, it's level. It's a typo, and you'd move on. That's not how our genes work.
I'm glad he agrees with me that this analogy is bad. I bet he won't abandon it, though.
If our genes saw that, it'd be like, I don't know what this is, and it would move on. You just destroy that piece of information by duplicating a letter.
Maybe, but many genes exist in more than one copy, and you might just as easily have also created new information. And if the duplication is 3 base pairs long, then you've actually probably just added a single amino acid to the protein, and depending on what it was, that could enhance, degrade, or do nothing to the function of that protein. So it all just depends. You can't say that any duplication destroys a gene. And of course, this is assuming that the mutation even happens in a gene. Most of them happen in eukaryotes in the intergenic regions of junk.
Then we have a deletion mutation. Take the word model and take the M out. It doesn't spell model anymore. Then we have a substitution mutation. We take the P out of probability and put a Z in there instead. Doesn't spell probability.
And to all these, the response is basically the same. The chemistry of genetics is almost nothing like the use of letters in English to convey messages in that language. Just like with insertions, deletions and substitutions can do from nothing to helping to hurting an organism. The fraction of genetic sequences that can be turned into functional proteins or can function as regulatory sequences is far higher than the fraction of possible arrangements of letters, spaces, and punctuation marks that can function as meaningful words or sentences in English. But what if we wanted to make this analogy of language to genetics better? Well, let's help Jay out a bit and give it a go. First, we need to switch languages. English is far too complicated and silly to be a good analogy to genetics at the level of nucleotide sequence. In fact, all natural languages are. Let's instead look at Tokipona. Tokipona is a constructed language created by Sonia Lang, a Canadian translator. She wanted a simple language, as simple as possible. Tokipona is said to have 137 words, but this is not really true. What it has are 137 lexemes. A lexeme is the minimum part of a word that has meaning. So for an overly complicated example, the word anti-disestablishmentarianism has the lexemes anti, dis, establish, ment, rein, and ism. That's 6. Most words have 1 to 3. In order, they mean against, undo, establish, the act of, advocacy for, and the belief in. Each one adds meaning to the word, and without them, the word would have a different meaning. Only the established part of the word cannot be removed. Similarly, the so-called words of Tokipona can combine to form new concepts related to their components. This means that any utterance in Tokipona is a collection of these 137 lexemes arranged in some order. Now that means that for any utterance in Tokipona, the possible lexeme space for Tokipona of that length is 137 to the power of the length of the utterance. So for a 4-lexeme utterance, the number of possibilities are 352,275,361. For English, it's astronomically higher. So high, I don't think I can actually calculate it. Of these, an extremely small fraction will be meaningful, but clearly more than with any 4 random English lexemes, especially since, unlike with English, every Tokipona lexeme can function as a word on its own. But what about DNA? Well, DNA is grouped not into lexemes, but into codons, sequences of 3 nucleotides, of which there are only 64. Each one is actually used in the genome, although most of them are redundant, which means that the actual number of instructions that they carry is only 21. So if we had a random assortment of 4 codons, no matter what they are at least in principle readable by the cellular machinery involved in translation and transcription. But we can see just from the orders of magnitude of fewer signal types in DNA that DNA is far simpler than even the simplest language devised by a human. As a result, just the numbers indicate that the functional fraction of sequence space in DNA is far, far higher than the functional fraction of lexeme space even in Tokipona, and that the functional fraction of lexeme space in Tokipona is itself far larger than for English. So this analogy using English is going to make people underestimate how robust the genome is to mutation by, at a conservative estimate, about 8 orders of magnitude, which is actually more than the number of orders of magnitudes that creationists are usually wrong by.
These are called single-point mutations. This is what mutations look like.
Well, it's what some kinds of mutations look like, and in a context that sets up expectations about them that are wildly inaccurate.
Now, here's what's interesting. You could ask a 6-year-old child, hey, what's your favorite book? And then they tell you some book. You say, if we took your book, closed our eyes, opened it up to some random page, stuck our finger in there, whatever letter we touch, we add an extra one of those right there. Then we close our eyes again, open up to another page, stick our finger in there, and whatever letter we touch, we erase that letter. Then we do it again, and whatever letter we touch, we take that letter out and put a different letter in, or maybe a number instead. If we keep doing that to your book, what will happen to it? Will it get better and better and more exciting and new characters and all that? The 6-year-old will tell you no. It'll get worse and worse. In fact, pretty soon I won't even be able to read it.
Yep, there it is. J is banking on the many orders of magnitude smaller functional fraction of English character space than even English lexeme space, which is already many orders of magnitude smaller than the functional fraction of nucleotide space. This is why analogies are dangerous. If you're using them with people who need them, then chances are you can mislead them when you go past where the analogy fails, and pretend it hasn't anyway. For people who understand the topic well enough to not need such help, you're just wasting their time at best, or showing yourself to be either stupid or dishonest in a case like this.
A 6-year-old understands this.
Yes, a 6-year-old might well be able to understand a book, but since the genome isn't a book, that doesn't really matter.
You have to be highly educated to not get this.
Or maybe it's that when you're highly educated, you can see where the analogy fails and realize that this argument is pointless.
And that's what happens with many of these PhD scientists. They're brilliant.
Brilliant enough to know when an argument isn't even talking about the topic, like this one.
But they either don't know about this, or they don't want to think about it.
No, they just aren't lying idiots like J. Seegert.
Because it's so straightforward. How do you make these random changes and make life forms better and better and better over millions of years? It's not going to work.
Except that we see it work. We see it work all the time. Humans evolved to eat a new food source, dairy. Bacteria evolved to eat nylon. Humans have mutations that make them hugely resistant to heart disease. We've seen coyotes evolve to become better able to live in urban environments. We've documented evolution in real time in lizards, birds, mammals, plants, bacteria, and fungi. Jay is basically telling you that cars couldn't possibly actually move people around while currently riding in one. If it didn't work, then we wouldn't be seeing it working.
But as challenging as anything that I might have shared has been so far,
Which is to say, not challenging to anyone with a high school level of understanding of the topic. Okay, not very challenging at all then. But let's brace for it to get more challenging since we really have no way to go but up.
the challenge for evolution gets much worse. This is where business picks up. If you've been bored out of your skull so far, this is where it gets fun.
Oh, goody.
I've given this talk many times. I have yet to ever have one single skeptic come up to me afterwards and talk about anything that I shared.
Wouldn't it be funny if I talked about it and then people were to send this to Jay Seegert at the email address? You probably shouldn't, but then he is a stooge for Christian nationalism, so whatever, f*** him.
They'll come up all upset. Well, what about all the evil in the world? So that's a great question. I can address it, but could you first address why I was here this evening, the presentation I gave?
I, for one, was planning to address this presentation and not planning to bring up the problem of evil. I'm not sure why I would. I don't really care to disprove the existence of God. That's a metaphysical question, and I'm here for science. At some point, do you think he'll actually tell us what his argument is instead of masturbating to how good he thinks it is? I already cut out some of it.
Well, what about carbon-14 dating? That's another great question. I'd love to answer that, but you maybe address like the whole DNA thing.
So far, I can't. Not because of how amazing the argument is, but because it hasn't even been presented.
How is the information written on our DNA?
Well, at no point has he defined what information is in this context, but for all actually useful definitions I've ever heard of or can come up with, it's encoded in the nucleotide sequence.
When you find out, that's when you'll easily understand evolution is not possible.
Get on with it. Yes, get on with it.
Get on with it!
So let's say you're looking at a segment of your DNA and you're reading it and it spells, was it a rat I saw?
Well, it can't because there are no letters in DNA, just 4 different chemicals. So it's kind of like asking me to watch this video and then asking me to imagine that the video smells purple. It's not really a thing
Kind of a weird statement. In English, we read from left to right.
I can do, because of fundamental category errors that Jay seems to be too stupid to realize he's made. But I guess I'll hear him out.
But you may have already noticed, you can also read that backwards. Was it a rat I saw? It's called a palindrome.
Hey, he said something that's true. Take a drink, everybody.
Kind of fun. Not a very meaningful sentence, but you can read it forwards and backwards. Pretty fun. This is what we've discovered about our DNA.
Wow, I sure do wish we would talk about DNA in this section on DNA. But yeah, there are palindromic sequences in DNA.
Much of it can not only be read forwards, it can also be read backwards.
That there are palindromes? Okay. Out of 3.2 billion base pairs, I'd be shocked if there were no palindromes in there.
But guess what?
Yeah, but it isn't in eukaryotes. That's mostly a thing that happens in bacteria with their much smaller genomes. So unless by our DNA, he just means any DNA on Earth rather than human DNA, he's wrong.
The challenge for evolution gets worse.
Is the what that Jay uses disgusting AI slop in his slides? Because that seems to be at least part of what the what is.
And the evidence of design gets better and better because our DNA doesn't have messages that read the same thing forwards and backwards like that example. It's more like this. Take a look at the word desserts. You spell that backwards, it spells stress, which is what I get when I don't get dessert.
Well, so far there hasn't been one. Just noting that there are DNA sequences that work in 2 directions isn't on its own a challenge to evolution. That's just a claim. In order for it to be an argument, there needs to be some reason to think that the claim is true, which it probably is, and that the claim is a problem for the truth of some other claim, and that's what we're lacking. It would be like me trying to tell Jay that Christianity is false because sometimes churches burn down. While that's true, that bare fact doesn't seem to obviously mean that Jesus didn't rise from the dead. I need to actually provide a reason why I think that Jesus rising from the dead would mean that churches don't burn down. Even then, Jay may well not find my argument compelling, but at least it would actually be an argument. So far, We're not even at that stage yet. We're just at the initial claim stage.
So we have two pieces of information. You get one piece when you read it one way, another piece when you read it the other way.
Which is not a palindrome. I don't think there's a particular word for this, but if there is, let me know in the comments, because I like to learn things. But again, what's the challenge here?
But again, picture this in our DNA. We can't just keep it there. We got to make this better and better and better and better.
It's important to keep in mind that DNA doesn't get better in some objective sense. What happens is that the phenotype that the DNA produces gets better adapted to its environment. But that's not better in all environments. In fact, it necessarily means getting worse and worse for other environments. Evolution isn't some great chain of being from lower organisms to higher, better ones. It's just adaptation to the local environment, which also means becoming less adapted to other environments.
And the only thing that is available to an evolutionist is copying errors. So let's make a mutation here. We'll just delete the T randomly. It doesn't spell desserts.
Yep. When you delete a letter from a word, the word is no longer the same.
But it also doesn't spell stressed. One change messed up two messages because it messed up the one way, and when you read it backwards, it messed up that message too.
And no one is claiming that a single nucleotide deletion in a gene isn't going to break anything. It would kind of have to, at least to some degree, since it would shift the reading frame of the gene, and the gene would probably lose its stop codon. But alternatively, it could also shift the reading frame in a non-functional region and neo-functionalize a section of the genome that was previously junk, and now a new protein is forming. Sure, it's not going to be a particularly useful protein at first, but it can evolve to become one if it has any biochemical activity at all, which it probably will. Indeed, it's often this kind of mutation in junk regions that cause brand new genes to be produced, and that's how we get orphan or taxonomically restricted genes. Now, it's not always a single point deletion, but that's one of the kinds of mutations that can do it. To use Jay's analogy, what if we had the word degserts, and then the reverse of stressed, but then we delete the G? Suddenly we went from no word to a word. And since there are far more parts of the genome that are gibberish than that are part of a functional region, the average single point deletion is more likely going to be the kind that I'm suggesting than the kind that Jay is pretending is the only kind of such mutation.
But we don't have little words in our DNA that go forwards and backwards.
Right, because DNA isn't made of words. It doesn't function like a language. This whole analogy is intentionally bad.
We have up to entire chapters of complex instructions you can read both forwards and backwards.
Do we? I don't even know what chapters are supposed to map onto here. So maybe we do, but I don't know what that's supposed to mean. Maybe the reason that no one comes up to him after his talks to address this section is because this section is barely even coherent. If I told you that the reason you should pledge $500 a month to my Patreon is that without it, Brain Scrap Analysis Collection Predict Choral Entertainment Highway Fool Crossing, you probably would less want to respond to me and more want to back away slowly in case someone who would say something that meaningless is dangerously insane. And that's sort of where we are with Jay. Also, you'll note that all he's done is say that deleting a single codon won't make a gene better, which isn't an argument that palindromes or reversible DNA can't evolve.
Let me give you an analogy to keep this simple.
The analogy was the problem in the first place, so I can't imagine going on to another analogy is going to help, but I can't stop him.
Let's say you all have a job working for a cell phone company.
Sounds terrible.
And it's your training to write the instruction manual to give to the manufacturing plant so they can make the phones. That's what you do.
Am I going to have to write a manual that can be read to give different but coherent instructions both forward and backwards? Is that where he's going with this?
Boss comes to you one day and says, hey, I got a project for you. I need you to write the chapter in the manual that explains how the phone's going to download apps from the web. You say, yeah, I can do that. He says, thanks. And he's walking away and kind of like Columbo, he goes, I just want one more thing. When you write that chapter, you have to write it in such a way that if we read your chapter backwards, it will explain how the phone's going to play music files.
Confirmed prediction. I'm already doing better in this one video than creationism has in the last 6,000 years on that front.
And you start laughing, you say, oh, that's a good one, boss. And your boss says, no, I'm serious. We only have so much room in the manual. Your complex chapter of instructions has to make perfect sense forwards and backwards.
Remember when we pointed out how much larger the functional fraction of sequence space is for DNA than it is for letters in English? Yeah, once again, we're back to that. The fact that something would be impossible in English doesn't mean it's impossible for DNA. Because again, DNA isn't a language. It doesn't function like a language.
That is humanly impossible. It cannot be done, not even close. You can't even program a computer to do that. I did programming for 12 years. It cannot be done. But this is what we're seeing in our DNA.
You know, I bet that if there was a computer programming language that only had 4 symbols, it could be done. The only programming language that I can think of that even comes close is Brainfuck, a language with only 8 characters, which is twice as many as DNA. Interestingly, it has a variation called reverse Brainfuck that actually allows all programs to be written in reverse or forward and still compile, and the language is Turing complete. Now, it's an unintentionally horrible way to program, specifically because in many ways it acts more like DNA than a programming language, but still, it can be done, and one of the key ingredients in getting reversible code on a computer was limiting the number of actual characters that can be used, and DNA does this even more than regular or reversible brainfuck.
You read a segment one direction, and it's a set of very complex instructions that code to make specific proteins that carry out a certain function in your body. Now you read that section backwards, it's a completely different set of instructions, coding to make completely different proteins that carry out a completely different function in your body.
Okay, and that's a problem for evolution because of what? It's clear that such DNA sequences exist, and any such sequence can be arrived at via mutation. So what's the problem here? Is it just, look at the trees, but it's DNA instead of trees?
2 major points with this. Number 1, particles banging together in nature, which is what evolution is. There's no purpose. They're just kind of interacting. Could never create a complex information system you could read both forwards and backwards.
Why not? I think I'm right that the reason no one comes up to address this is because there's nothing to address. It's just incredulity. Evolution can't do it because he thinks it can't. Okay, cool. That's not an argument. There's very little point in addressing anything he said here, because he hasn't actually said anything that provides a reason to address it. Like if I told Jay that I didn't believe Christianity because the story of the feeding of the 5,000 involves a lot of people, he probably wouldn't find that something that's really worth addressing, beyond saying, why is that a problem?
And secondly, even if you had something like that, making random changes to it will not make it better and better. It's going to make it worse and worse. That's so easy to understand.
No number of analogies, no matter how bad they are, will overcome the simple fact that mutations observably do increase fitness both in the lab and in the wild, including in humans. Any creationist argument that there are simply no beneficial mutations doesn't need to be based on theoretical problems with beneficial mutations, but instead it needs to address the simple fact that they're observed to happen. So even if you don't know what's wrong with a particular argument, like that DNA has a large functional fraction of sequence space when compared to natural human languages, or most computer programming languages, as is the case here, you don't have to. Beneficial mutations are observable, and so just like any arguments about how it's physically impossible for a bumblebee to fly can be defeated by pointing out that they do fly, any argument that beneficial mutations are impossible can be defeated by pointing out that they do occur.
But guess what? It gets even better than that.
Well, that was as much nothing as everything that came before it, so it can't be worse.
We have overlapping information in our DNA. Take a look at this weird phrase, I like chocolate later that evening.
Chocolater isn't a word that I'm familiar with.
Why is it weird?
I think it's the made-up word.
Because it's 2 phrases that overlap. I like chocolate, which is true, and then later that evening.
Oh, so just more things you can't do in English, but that you can do in DNA. Because for the trillionth time, DNA isn't a language, and it doesn't act like one.
It overlaps in the middle, L-A-T-E. It shares those words. Overlapping messages. All right, again, we have to improve this. We got to make it better and better over time. Let's introduce one of our wonderful mutations. We'll take the E out and put a Z in.
And of course, we're once again bringing back one of the big reasons that English is a bad analogy for DNA. It has way more possibilities for what a token can be in the alphabet with 26 letters and a host of other symbols. I feel like so far this whole video can be summed up with the phrase, DNA doesn't operate anything like written English.
It doesn't spell I like chocolate, and it doesn't spell later that evening. One random change messed up 2 messages because they overlap. Wow. We don't have a few letters that overlap in our DNA. We have up to entire chapters that overlap each other. Can you imagine?
I think maybe he means chromosome by chapters. But if that's the case, then this isn't true. It might be true if by chapter he meant gene, but then it gets way less impressive. I'm not really sure what he's doing here. This is why you really shouldn't use analogies for the genome. They're usually more confusing than helpful.
2 chapters in a book, you start reading from here to there, and it's 1 chapter, and then you start from here to there, and it's another chapter, and they actually overlap each other.
I guess he does mean that the chapters are genes, and yes, I can imagine that. It would be very annoying to read, but I can imagine it.
That's what we have in our DNA. But guess what? It gets even better than that.
This framing device really sucks, since it's never true, and now he's reversed it for some reason. I think he just forgot what he was doing.
We have spliced information in our DNA. Look at the same phrase I had up before. I like chocolate later that evening. Let's underline a few segments and then bring them down below. And it spells I like her hat.
This is actually an interesting thing that eukaryotes do that bacteria largely don't. In bacteria, genes run continuously and aren't really broken up. But in eukaryotes, they're divided into exonic regions that actually contain the coding sequence of the gene, and introns which do not, and are cut out of the RNA before it can be used to make a protein. But different sets of exons can be used to produce different proteins. And I think that's what he's talking about. I'm not sure what about this can't evolve, but that's the theme for today. Just pointing out that something exists, as if doing that is an argument for or against anything.
That's a spliced message. We took a few random things out of the main message, put them together, and we got an additional piece of information. This is what we see in our DNA. We have spliced messages. Again, we need a random mutation to make this better. We'll just randomly delete the H. It doesn't spell I like chocolate, but it also doesn't spell I like her hat. One change messed up 2 messages.
I just wish that meant anything for the question of whether evolution is true.
But we don't have just a few letters that get spliced in our DNA. We have up to long sentences and short paragraphs.
Again, with using analogies that don't clearly map onto the concept of genetics. If a chapter is a gene, then what the heck is a sentence or a paragraph? What's a word in this context? I don't know, and I don't think Seegert does either. I think he just wants you to think that DNA is neat, and that therefore, for some reason, it has to be a miracle. As if nothing that nature produces can be neat. Well, I've been to a lot of neat natural places, and seen a lot of neat natural things. Nature can be very neat.
As an analogy, let's say you were reading the biochemistry textbook from cover to cover. It's very technical, you just learned a lot of information. Now go back and take random sentences and short paragraphs from throughout the book, put them together. Oh, we got another chapter.
That's actually really easy to do. Basically what he's describing is just a stereotypical ransom note with the words cut out of different bits of a magazine or newspaper. That might actually be the least impressive of the various facts about DNA that he's given us.
You couldn't write a book to do that.
I actually think it would be harder to write a book that couldn't do that, but whatever.
But that's what we see in our DNA, and guess what? It gets even better.
How many times can one man say look at the trees in one talk? The closest thing to an argument he's made is that I couldn't write a book that does what DNA does, and in most cases, that's true. But also, I can't build a house that does what a whale does. Who cares? Why would I need to? Why would I want to? How would that mean that whales are miracles? I also can't build a telephone that does what a hurricane does. These things are very different. They don't do the same things, and they don't come about by the same processes. And if you want to say that they do come about by the same process, which is more or less what he wants to say for books and DNA, then all the pointing out how different they are does is undermine that.
Than that, we have embedded messages in our DNA. So take a look at this sentence. Can you show Mike Owen checks from Oliver's latest facts and set it on the desk?
Is this just going to be putting coded messages in text? Because that's not hard to do.
Let's circle every 8th letter and then bring them down below. And it spells chocolate. There's a theme going on here. It's my talk. I can do that.
Yep, so first, this has been done with text for thousands of years. It's not special or new. But also, I don't have any clue what this refers to that DNA is doing. DNA doesn't work by pulling out every nucleotide based on a modulo function, which is what he's describing here. Also, modulo is one of those fun mathematical operators you don't normally learn in school, but I actually use it all the time. It basically returns the remainder after dividing a number by another number. A modulo has the format of A mod n, where A is the number you're checking and n is the number you're dividing by. So if we took, say, 19 mod 2, the answer is 1, because 19 is equal to 9 times 2 plus 1. That plus 1 there is the remainder. 19 mod 7 would be 5, because 19 is equal to 2 times 7 plus 5. So what he's doing is, in computing terms, saying, check each letter where the variable a is equal to the index of the letter in the string, and print each letter with a mod 8 that equals 0. It's a fun thing to do in cryptography and computing, but I don't see where this is happening in DNA. Maybe if he stopped with this stupid analogy, I would.
But again, we need a random mutation to make things better and better, so we'll just randomly delete the H. It messed up the main sentence up there, didn't it?
Yeah, and does he think anyone disputes that mutations can change things, including breaking them?
But now it's going to mess up the embedded message because all of the letters after that letter we deleted, they're going to shift over one spot. And now it spells this, which is meaningless.
I mean, Calaxid might be meaningless, but I'm at a loss as to how this maps onto any genetic process. However, something similar does occur in terms of shifting DNA as a result of insertion or deletion. Genes exist in something called an open reading frame. In order for an open reading frame to exist, it must have a start codon, then some natural number of codons, then a stop codon. Now, insertions and deletions can disrupt this, since if the number of nucleotides inserted or deleted isn't evenly divisible by 3, then the stop codon will shift and no longer exist within that reading frame. But also, this can create open reading frames. Remember, there are only 4 nucleotides, and they come in groups of 3, so there are 64 codons. Of these, 3 are stop codons: uracil adenine adenine, uracil adenine guanine, and uracil guanine adenine. So of any 3 random nucleotides, the chances that they will form a stop codon are 4.6875%. Which isn't high, but given that at least 80% of the 6.4 billion base pairs of the diploid human genome are junk, that means that in the junk there are about 80 million stop codons just waiting in the junk DNA. There are only about 26.6 million start codons in there, but what that means is that for any given start codon, there is likely to be a stop codon just waiting for an insertion or deletion to create a new open reading frame, and thus create a brand new gene, and by the very mechanism J is dismissing.
One random change messed up the main message, and it also messed up the embedded message, and this is what we have in our DNA.
I don't think it is, but okay.
There's embedded messages like that. It's amazing.
I'm not really sure what's amazing about a modulo function, but since near as I can tell, that's not even a real thing in DNA, it's extra not amazing.
But guess what? It gets even better than that. We have encrypted messages. I actually had 3 interviews with the CIA to work in their cryptographic analysis division.
If that's true, it might explain his enthusiasm for modulo-based codes, and why he seems to imagine that they're in the DNA. But also, I can't imagine what encryption he's talking about. Encryption is encoding information so that only the sender and receiver can interpret it, and it's most often accomplished today with complex mathematical operations that would take a computer millions of years to crack without prior knowledge of the operations, but fractions of a second with it. Nothing like that happens in DNA.
A creepy story for some other time. Was kind of weird, but
this whole talk is already extremely weird. I suspect a story about a CIA job interview would be less weird than most of what we've heard.
Encrypting messages, coding and decoding messages. This is how it works. We have this phrase, kind of meaningless, jumbled letters going across the screen. Doesn't seem to have any meaning.
I don't know, it looks like a simple substitution cipher that didn't even bother to take out the spaces.
But what if you found out there was an encryption key? Meaning everywhere there's an H, up there it's really an A. Everywhere there's a B, it's really a C. Everywhere there's a Y, it's a T.
Then I would say that I was right. It was the most basic of substitution ciphers. It's not even a rotating cipher. This is pathetic and barely counts as encryption. It's the kind of encryption an amateur could break during lunch on a weekday. And also, it's not a thing that happens in DNA. The only thing I can even think of is codon assignment, where each grouping of 3 nucleotides is assigned to an amino acid or a stop function. Start is also the codon for methionine, which is the first amino acid in all proteins. But this isn't a code meant to keep out outsiders. It's just a basic form that the encoding takes. It's the plain text. It's no more a code than standard English orthography is a code, which is to say that while it is, it's the lowest level of code and intended for ease of use and interpretation, even if it often falls short of fully meeting that goal.
So if you make all the substitutions, it actually spells this as an encrypted message. That's one way of doing data encryption. It's very complex. There are other methods as well.
It's literally the simplest method. All the other methods are more complex.
But let's take a minute to think through what would be required in nature to create an encrypted message system, keeping in mind there's no God, no creator, no designer. Particles just banging together. You got a big bang with some hydrogen, helium, and a little bit of lithium, and these particles are banging together, and billions of years later, we got encrypted message systems.
But we don't, though. At least not that I can see.
What would these particles have to do banging into each other? This is what they would need to do. First of all, they would have to create and develop a language system using symbols.
Well, DNA isn't that. DNA isn't a language. It doesn't speak a language. It doesn't have words. It doesn't have thoughts to convey. It's just chemistry. Now, sure, we can talk about codon assignments in genetics as a code, but it's fundamentally a different sort of thing. It's not encoding a language. It's not symbolic. It doesn't require that a mind read and understand the message. We just use words like code and message as analogies to make this easier to talk about. Jay seems to be confusing anthropomorphic analogies for literal truth, which is really dumb, but it's also something I kind of see a lot with creationists. Another example is when Randy Galuza complains that in order for nature to select something, it would have to have a mind. I guess the basic human tendency to talk about things as if they have agency, even when they don't, for the sake of ease of communication, is far too complex a thing for the average young earth creationist to fathom. Or, maybe they're just lying shitheels.
So these particles would have to decide, if we have 3 sticks like this and put them together this way, we're going to call that an A. And if we have 3 shapes like that and put them together this way, we're going to call that a B. They would have to create an entire alphabet.
What are we doing here? This might be the start of an interesting world-building exercise for a fantasy series, but it has nothing to do with genetics, evolution, or biology in general.
By particles banging together randomly over time. Then they would have to create and define words. So when they put those 4 letters together, it's going to represent that object. They would have to create an entire dictionary and definitions by particles banging together over time.
Okay, so at no point does he actually explain what the hell this has to do with evolution or genetics, so I'm skipping the rest of it. He just keeps on describing particles making a conlang, then making a cipher for it, and asking how that could happen. And of course the answer is that it couldn't, and no one thinks that it did. DNA isn't a cipher, although since it exists and we can synthesize it with arbitrary sequences, it can be used as a cipher by humans, and it has been thus used. But that's not how it's used without intelligent intervention. Maybe if we discovered that the genome was also a secret cipher for Genesis or something, that might be compelling evidence of the created nature of the genome. But it's not. We have one more section in this look at the DNA part of the talk, and I cut out all the repetitive bits, so let's dive into it.
There's 3D information.
Yeah, kind of. I don't really like talking about it in terms of dimensionality in this case, but I know that actual experts sometimes do. I think it gets messy and doesn't really convey what's going on very well, but hey, let's hear them out. I'm sure it'll just be another, wow, DNA does a thing that a book typically doesn't.
It's actually 4D information, which has to do with time. I'm skipping that one.
He does that a lot. I feel like it might just be a tactic to convince his audience how smart he is.
3D information in our DNA. This is a little bit harder to depict with PowerPoint, but I'll do my best.
Learn Blender. It's free and not as hard as you think. Now I say that acknowledging that I've been using it for a decade, so whatever.
When our DNA makes proteins, they're not these little mini ladders. They're these highly, highly complex 3-dimensional folds. If they don't get folded just right, they're useless. And then they're decomposed, individual components are reused.
That's true.
So it's got to be folded just right, and it's unbelievably complex process. I wish I could show you a video right now of all that goes on. It would blow you away.
He could, and in fact, I will. That wasn't so hard now, was it?
But proteins are these complex folds, like a lock and a key. It's got to be just right to work. So I put 7 words up here on the screen, kind of random words, and I'm going to fold the words. But all I can do in PowerPoint is stack them on top of each other. So when I stack those words on top of each other that way, you may notice going up and down now, you see an additional piece of information, an additional word that shows up, the word success. Well, obviously, if we delete letters and change letters, we're going to mess that up. But if we don't fold it right, if we do this, we lose that piece of information.
Yeah, but protein folding isn't random. Folds occur because of electrostatic attraction between different parts of the protein. Some parts have minor negative or positive charges and so attract or repel other parts of the protein. Letters don't do this. DNA doesn't carry folding instructions. The folding is set by the amino acid sequence, which is one-dimensional. So far, we're not even at a second dimension in DNA, never mind 3. Now, that doesn't mean that proteins can't misfold, but that's because of some other chemical that messes with them while they're in the folding process. It's not just a thing that happens for literally no reason.
And that's what's happening with our DNA. We got all these other levels of information I mentioned, but then you also have some nucleotides, those rungs on the ladder here, some other rungs here. When this gets folded over, now they're on top of each other and you can read it up and down. It's additional information.
Is he confusing protein with DNA? DNA only ever gets read along the sugar phosphate backbone of the DNA. It can't be read by skipping the tracks, so to speak, because the chemical that reads DNA, RNA polymerase, works by traveling down the backbone in sequence, and if it stops to attach to a new sequence of DNA, the RNA it's polymerizing will float off, which is what happens anyway when it hits a stop codon. Jay could really benefit from an Intro to Genetics undergrad class. He can even just audit one. That's usually free.
It's unbelievably complex.
Well, it is, but evolution predicts complexity. In fact, even physics predicts complexity, because it's thermodynamically favorable in non-equilibrium systems. You see, the universe tends to spontaneously do things that increase entropy. In fact, in physics, it's fair to say that in many cases, spontaneous and increases entropy are the same thing. And in a situation where there is a constant energy gradient, such as on Earth, things that increase entropy faster are thermodynamically favored, and complex structures like life do that. The more complex, the faster they do it as a rule of thumb. This is because more complexity means more steps, which means more processes that increase entropy. Which means that just from a physics standpoint, if a system can complexify and thereby produce entropy in the system faster, it will complexify. Life is such a system, so even without getting into the genetics or biochemistry, just thermodynamics says that life should get more complex, and that after 3+ billion years of it, it should indeed be staggeringly complex. That's not a bug, that's an expectation. Further, at the level of population genetics, just genetic drift favors complexity. So we should expect that organisms complexify regardless of whether it's adaptive, and that they will simplify only when there is pressure to do so, as there often is in the case of parasites, which are often radically simpler than their relatives.
So wrapping this up, certain things look pretty good. From a certain distance or a certain angle, like the bright red BMW, we envisioned opening that hood to see the beautiful engine. We just opened the engine on evolution, or the hood on evolution, and the engine's missing.
No, we opened the hood on a weird invented straw man version of evolution. The reason it doesn't have an engine isn't because evolution doesn't have mechanisms that work, it's because rather than checking evolution, Dan painted headlights on the cardboard box his couch came in, then cut doors into it and wrote vroom vroom on the side, called it evolution, and then was shocked to discover that his cardboard box can't drive him anywhere.
There's nothing there. Here's a quote from a geneticist.
I don't care, I'm done with quote mines. Data and arguments or f*** off.
God is the one who created everything.
I have no problem with general creation by God. Just don't deny science over some kind of special creation that isn't in evidence.
His fingerprints are all over it.
If you see the fingerprints of the divine all over reality, that's fine. But if you want to argue that as part of science, you're going to actually have to do that. Not lie about it and deny most of it like Jay does. Good luck to you.
And if what I just presented as evidence for design doesn't count as evidence for purpose or design or God,
which it doesn't, since it was just a bunch of lies combined with the genetic equivalent of, look at the trees. That's not evidence of anything other than the lack of integrity common to professional young earth creationists.
please give me an example of what you would accept as evidence.
Sure thing. It would take the spontaneous formation of a complex cell despite a human not causing such a thing, and it happening in a situation where the requisite materials do not exist. If geology actually revealed a global flood, that would be evidence. If there were any archaeological or linguistic evidence for the exodus and conquest of Canaan, that would be evidence in a roundabout way. If the time to the most recent 4 ancestral alleles for most parts of the genome of all organisms coalesced at about the same time, presumably 4.5 millennia ago, that would be evidence. If the number of species of terrestrial tetrapods could be fit into the time frame of the Noah's Ark story, that would be evidence. If we found that some of the mutations that are required for evolution were physically possible, but they just didn't happen anyway, that would be evidence. If the genetic similarities between morphologically similar species were only in the functional parts of the DNA, and even then only in the parts that determine gross morphology, then that would be evidence of separate ancestry, which technically doesn't demand intelligent design, but it seems to me like it at least leans that way.
I've asked skeptics that very question. They'll come up to me, there's no evidence that God exists or that creation is true.
I'm not here to assess the question of whether God exists. It's not a question that I can figure out a way to test scientifically, and this channel is primarily about science, so as far as I'm concerned, it's off topic.
I asked him a simple question, very respectfully.
No, he didn't. He asked the question politely, I expect, but respectfully, no. Part of respect for people is that you not lie to them, that you actually be intellectually honest, and that is something that I don't think Jay even can do. He might have thought he was being respectful, but he's wrong. Jay doesn't respect science, he doesn't respect others, and I suspect that he doesn't even respect the Bible.
They say, okay, tell me, what would you accept as evidence for design or creation? What would that look like? If you saw A, B, or C, that would definitely be evidence.
Since I don't want to repeat myself, I'll summarize by saying things that are both true and that actually point towards design.
I don't know, but I know there's no evidence.
I feel like this isn't an actual conversation that happened. I was able to provide potential hypothetical evidence immediately that would satisfy me. Now, don't get me wrong, it actually is the case that if you say none of the alleged evidence for a claim works and I don't know what might support it, that's possible. For instance, I don't know what evidence could support the claim that there are invisible, insubstantial ghosts floating around me that I can't interact with in any way, but that are always judging me harshly. I also know that no evidence I've ever seen would actually indicate that such ghosts exist.
Wait a minute. If by your own admission you don't even know what the evidence would look like, how do you know it doesn't exist?
I don't. I just know that I haven't seen it. I can't live my life believing everything for which there might be evidence. That's an infinite number of mutually incompatible things. If Jay is convinced of a claim and he wants to convince those who do not accept it, it's on him to provide evidence. If he fails, then it's not the responsibility of those who are unconvinced. Now, it is their responsibility to actually have reasons for rejecting his supposed evidence. Otherwise, they're not being skeptical, they're just denialists. And indeed, there are denialists out there who accept evolution.
In fact, if you don't have criteria that you use to judge what counts and what doesn't, you can't even have this conversation.
Sure, but I can have criteria without knowing exactly what would meet them. For instance, for the example of the invisible, insubstantial, judgmental ghosts, I know that evidence for them would be any verifiable fact that makes it more likely that they exist than that they don't. I just don't know what fact would meet that criterion. That that's the case doesn't mean I'm being illogical by not believing in the ghosts.
So they will make bold claims with nothing to back it up.
Nothing except math, measurements, statistics, confirmed predictions, experiment, etc.
They say the evidence doesn't exist, but they can't even tell you what it is they would expect to see. Yeah, I expect to see this. If I saw it, I would say there's a God, but I don't see it.
Well, that's a different question then. Is evolution true as we currently understand it? I answered the question about evolution. I don't care about the God question. But yes, I can think of evidence that would convince me of both general theism and particular God concepts.
They would look at their laptop and they would say, of course it's designed. Why?
Because we can talk to the designers. We know it's not self-assembled. We can investigate the history of computer design. None of that is true for biological organisms, so we can't use the same logic to assign design to organisms.
Because you have all these independent parts that are really complex on their own, and they're arranged in such a way they can perform a function that's outside of themselves by working together.
Nope, that's not enough. That can occur on its own if the possibility for self-assembly and reproduction exist, which they don't in a computer, but do in the case of things like plants and animals, fungi, bacteria, etc. Complexity and function don't even factor into the recognition of design. People think they do. Those people are wrong, and it often leads them to the wrong conclusion about whether things are designed. Jay is such a person.
That's evidence of design. We don't question that. We have criteria. We understand that.
Sometimes you are wrong in life.
So then when you look at DNA, which blows this laptop away.
Wait, did someone weaponize DNA? Oh, he probably means figuratively. Boo. I want a DNA cannon, gosh darn it.
Why wouldn't they say that's evidence of design? You know why?
Because it's not. Design tends to be simple to the degree that it's possible. DNA is, if anything, overly complex and hugely wasteful. Complexity doesn't require design. DNA has mechanisms for replication and reproduction that do not depend on intelligence. Nothing about DNA in any way indicates that it was designed, and ranting about how cool it is doesn't change that, even though it is true that DNA is very cool.
Because it's a heart issue.
And we're back to, you only believe in evolution because you're horny. Okay, my acceptance of evolution has nothing to do with my heart and everything to do with the data. Evolution didn't make me stop believing in God, nor does it for most Christians who accept it, which is a large portion of Christians, possibly the majority, although I don't have a poll so I can't say for certain.
It's not an academic debate. They don't want to see evidence of design because if there's a designer, he would be the ultimate authority. They don't like that.
That doesn't follow at all. Jay just assumes that if there's a designer, it must be the God that he believes in, but that's not true. It could be a completely different God who just likes life and doesn't give a damn about what people get up to. Maybe life was designed by Nurgle so he could just watch it rot and decay only to bring forth new life. Maybe it was Korn who created life, because otherwise where would he get his blood and skulls?
Even though this is powerful evidence,
Which it's not.
do not be naive thinking if you just tell your atheist neighbor this, you'll say, oh, I didn't know that. Let me go to church and worship Jesus with you.
Look, if you want to get your atheist neighbor to go to church with you, why don't you just become friends? And then when you're close and you care about each other and are genuinely interested in each other's lives and well-being, why not invite them to church so that they can experience something that you find profound and meaningful with you? I've been to many religious services for religious traditions I've never been a part of. I went to some of them to satisfy my own curiosity, or to share the experience with someone I cared about who was a part of that tradition. Maybe your friends will want to keep going. Maybe they won't. But what won't have happened is you lying about science to them in some stupid effort to win their soul. Instead, you'll have formed an actual human connection with another person where you can share what's important to you. I think that's pretty important. Look, after this, he just goes on and on about how skeptics probably won't buy into this amazing evidence. Yeah, probably not, but I don't care. He also does more commercials for his ministry, as if the 10 plus minutes at the start of the talk wasn't enough. Then it's a Q&A, but the questions also involve him telling us what he wants to do with his ministry, so I'm calling it. I'm done with this guy. He understands neither the basics of genetics, nor what skepticism is, nor that the possibilities are not limited to Christianity and atheism. He's an idiot, he's a liar, but I wish him well in his romantic partnership with Sal Cordova and John Sanford. Maybe evangelicals would chill out more if more of them were in gay thruples. I don't know. What I do know is that this is another video done, so if you liked this video, please hit like and let me know what you liked in the comments. If you didn't, then hit dislike and let me know what the problem was. Either way, I hope you subscribe and check out the channel memberships and my Patreon. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tovand, Tapioca Weasel, Max Cherry, North Texas Fossils, John Ackerman, Sphincter of Doom, Regios, Landon, Ian Chen, Eleron Teller, Phil Gevara, Kelvin Brostek Van Manen, Joshua Geese, Volis, Dan Sheedy, The Plastic Mouse, Arrow Dodger, and Gordon Loves Science. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 15% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos months before they come out for the general public. Thanks for watching.